See from me. That section of the class cannot see the screen. I would appreciate if you sit on this side so you'd be able to see the screen as well, because I'll have to sit somewhere in the middle. I see. All right. We continue from where we had left off at in the last lecture. What we had done last time was look into all sorts of endogenic processes, not exogenic, just endogenic processes. We had looked into uh, sudden movements and gradual movements. Okay. तो जितने भी डायस्ट्रोफिज्म के प्रोसेसेस थे जैसे पैरोजेनी और ओरोजेनी वो कर लिया था. How many of you do not understand Hindi? Raise your hands. Anybody here in the classroom who doesn't understand Hindi or Marathi? Okay, ठीक है, we are good. If you feel मैं एक ही language में बहुत explain कर रही हूँ, I'm trying to explain a lot in the same language. Raise your hand, tell me, I'll change that. Right? ठीक है? Here we are. तो हमने last time ये सब किया था. We had looked into the volcanism and earthquakes. वो देखे थे, उसके effects देखे थे, and so on and so forth. और उसके पहले हमने pyrogeny and orogeny consider किया था. Okay? उसकी mountain building का process कैसे होता है, and continent uplift या subsidence का process कैसे था. Alright? Based on that, we will cover the PYQs today. उसके ऊपर based जो PYQs है वो cover कर लेते हैं. Okay? So the first one, question 115, which of the following statements with reference to shadow zones is an event of an earthquake? In an event of an earthquake is are correct. Okay? So we are talking about shadow zones during an earthquake. इसमें से कौन सी statement सही है ये बताना है आपको. First statement says zone between 105 and 145 degrees from the epicenter was identified as the shadow zone for both P waves and S waves. Is that correct? शैडो जोन दोनों पी वेव्स एंड एस वेव्स के लिए है. हाँ करेक्ट. दैट इज द इंटरसेक्शन पॉइंट राइट. वो सेट्स में जैसे एक इंटरसेक्शन होता है ना, कॉमन जो पार्ट होता है दोनों सेट्स में, तो ये दोनों के लिए दिस पर्टिकुलर थिंग इज एब्सोल्युटली इट रिंग्स ट्रू. We were on volcanism. Okay, so here दोनों P waves and S waves के लिए shadow zone is going to be 105 to 145. In case of a secondary wave, the shadow zone will be extended generally beyond 105 degrees. But in case of a P wave, वो clearly 105 to 145 होता है. Okay, so that statement holds true. The shadow zone of P waves is much larger than that of S waves. Is this statement correct? कि P waves का shadow zone, ये वाला statement सही है. Okay, लेकिन shadow zone of P waves S waves से बड़ा होता है क्या? नहीं होता है. नहीं, S waves का shadow zone बड़ा होता है. 105 onwards वो completely shadow zone हो जाता है. तो clearly P waves का shadow zone बड़ा नहीं है S waves से. Okay, P waves का छोटा है, S waves का बड़ा होता है. All right, so we go here with we will go with only one. है ना, one only is the option. सही है ना बाबा? One only. Okay, we'll just go with the first statement that being correct. Next वाला देखते हैं. Which of the following statements is correct? Oceanic trenches are very significant in the study of plate movements, and oceanic trenches are associated with active volcanoes and strong earthquakes. First statement सही है कि oceanic trenches significant होते हैं. Second statement सही है कि oceanic trenches, अच्छा ठीक है, we'll go with that. Oceanic trenches are associated with active volcanoes and strong earthquakes. Where do we associate oceanic trenches with? Which process or activity do we associate oceanic trenches with? We associate them with subduction zone. Okay, वो जो subduction zone होता है, when two plates come together and clearly beyond a certain point they cannot move forward, तो one plate is subducted beneath the other plate, और वो जो subduction zone है आपका, वहां पर usually आपको trenches बने हुए मिलते हैं. ये जो V shape दिखाई दे रहा है ना, That is the oceanic trench that is usually formed. Okay, तो ये जो oceanic trenches होते हैं, they are definitely significant in the study of plate movements. Okay, कि वो जब हम प्लेट मूवमेंट स्टडी करते हैं तो क्लियरली ओशियनिक ट्रेंचेस मैटर करते हैं, क्योंकि जहां कहीं ओशियनिक ट्रेंचेस है वहां क्लियरली सबडक्शन जोन्स होते हैं. ओके, and they are associated with active volcanoes and strong earthquakes. Yes, they are most certainly associated with active volcanoes and strong earthquakes. Active volcanoes तो होते ही है because volcanic activity होगी, लेकिन स्ट्रॉन्ग अर्थक्वेक्स इसलिए भी होते हैं क्योंकि यहाँ पर यूजुअली आपके सारे डीप फोकस अर्थक्वेक्स होते हैं, राइट. दिस दिस ये जो जोन है जहां पर वो सबडक्ट हो गया है प्लेट, ये जो जोन है दैट इज गोइंग टू बी अ वेरी एक्टिव साइस्मिक जोन. ओके, यहाँ पर हमेशा इसके अलोंग भी सारे अर्थक्वेक के फोकल पॉइंट्स होते होंगे. ऑलराइट, सो वील गो विथ ऑप्शन बोथ 1 and 2. वी आर गोइंग विथ 1 and 2. Next question, which one among the following volcanic island chains is not associated with the mid-oceanic ridge? Mid-oceanic ridge माने अटलांटिक ओशन के ठीक बीचों बीच देयर इज प्लेट्स पार्ट करते हैं, देयर इट्स अ डाइवर्जन बाउंड्री. सो क्लियरली वो प्लेट्स दूर चले जाते हैं, नीचे से लावा का अपवेलिंग होता है, एंड बिकॉज ऑफ दैट एक कंटिन्यूअस माउंटेन्स वोल्केनिक माउंटेन्स का एक रिज मिल जाता है आपको. ओके, एंड वो इट नॉट ओनली थ्रू द ओशन फ्लोर ऑफ द अटलांटिक बट इट एक्सटेंड्स वे अप टू आइसलैंड. यहाँ ऊपर जो आइसलैंड है वहां तक एक्सटेंड करता है. सो वी आर सेइंग यहाँ पर आइसलैंड है, राइट, तो ये पूरा का पूरा ऐसा फ्लोर पे, ओशन फ्लोर पे, एंड देन थ्रू आइसलैंड वो आगे जाता है. ओके, सो वी आर सेइंग दैट इज द मिड अटलांटिक रिज. नाउ आपको ये बताना है कि इसमें से कौन से आइलैंड्स वो मिड ओशियानिक रिज के साथ रिलेटेड नहीं है. अजोरस, असेंशन, हवाईयन या ट्रिस्टन डुकुना. ऐसे ही अच्छा लगा नाम. हवाई आइलैंड्स, एब्सोल्युटली. हवाई आइलैंड्स आर famously lie in the Pacific Ocean. Okay, come inside. Hawaii Islands famously lie in the Pacific Ocean. So whether or not you know where Azores are or Ascension are, Tristan da Cunha, you should know that Hawaiian Islands are the ones जो Pacific में lie करते हैं, तो clearly उनका Atlantic से कोई वास्ता नहीं हो सकता. ठीक है, so here we go with Hawaiian. This is world geography plus this particular chapter. Anyways, question 109, which of the following statements regarding earthquakes are correct? The point on the Earth's surface directly above the focus is called the epicenter of the earthquake. Earthquakes generate primary and secondary waves that radiate outward from the earthquake focus, and deep focus earthquakes are likely to cause more damage than shallow focus earthquakes. 1 and 2 are correct, you say. Let's see. We are looking at the point on the Earth's surface directly above the focus. We are saying अगर यहाँ पर focus होगा, if this is the focus, focus is always in the body of the Earth. Okay, वो कभी surface पे नहीं होता है. Surface पे क्या होता है? Exactly above the focus आपको क्या मिलता है? Epicenter. Okay, यहाँ पर आपको epicenter मिलता है. Focus का एक और नाम क्या होता है? Hypocenter. Absolutely correct. Okay, so focus जो होता है that lies, they are saying कि वो जो Earth के surface पे directly above the focus जो point lie करता है उसको epicenter बुलाएंगे. उसको सही है, उसको epicenter बुलाएंगे. Earthquakes generate primary and secondary waves that radiate outward from the earthquake focus. सही है, यस, ये भी सही है कि earthquake के फोकस से फर्स्ट वेव कौन सी निकलती है? प्राइमरी वेव्स. ओके, थोड़ा सा लैग होता है, कुछ सेकंड का लैग होता है. नेक्स्ट वेव कौन सी आती है? सेकेंडरी वेव्स. सो प्राइमरी एंड सेकेंडरी वेव्स दोनों फोकस से निकलती है और बाहर की तरफ जाती है थ्रू आउट, एवरीवेयर, ऊपर भी नीचे भी, साइडवेज, एवरीवेयर, लेफ्ट राइट एंड सेंटर, ये सारे वेव्स चले जाते हैं. ओके, so this is also true. And third statement says deep focus earthquakes are likely to cause more damage than shallow focus earthquakes. Nope, never ever. Deep focus के बारे में क्या कहा था? See, we had said कि suppose this is the earth. Okay, तो deep focus earthquakes say maybe 300 to 700 kilometers नीचे होंगे. Okay, from the surface of the earth. तो यहाँ से जो waves निकलेंगे वो दूर दूर तक जाएंगे. So these earthquakes are widely felt. दूर दूर तक feel किए जाते हैं. But are they that severe? Can they cause much damage? No, clearly not, because by the time the primary and secondary waves reach the surface and convert into surface or rather, transition. Oh, hello, people at the back, at the corner. Get up from there and come and sit over here. Both of you. And you, gray color shirt, come and sit in the front. Blue color shirt, get up from there. I asked you to come and sit in the front. Those are also your friends and you plan to continue to talk to them henceforth also. Anyways, the deep focus earthquakes clearly widely felt होते हैं, they are felt over a wider distance, they are felt over a larger distance, the radius for feeling the earthquake is really greater, but more often than not they are not very intense, they are not very severe. Okay, ठीक है. What about shallow focus earthquakes? Shallow focus earthquakes में primary and secondary waves very quickly reach the epicenter, they are very quickly generated into, बहुत quickly convert हो जाते हैं into surface waves. Surface waves are set up and those have a great amplitude and hence they can cause more damage. So it is always the shallow focus earthquakes that cause more damage, okay? Not the deep focus earthquakes. So we'll go with 1 and 2. That is going to be the answer. Right now. Next one. Which one of the following is not an example of a fold mountain? You at the back. Yeah, the one you were smiling right now. Can you stand up? Yeah. Take a guess. Why? That's a general guess. Can you try using any information you might have had earlier? Let's make it an educated guess, where you actually use information you have at hand and try to reason why this should be the answer. Person sitting next to you. Why Mount Fuji? Do you agree with the answer? Is Mount Fuji not a fold mountain? Huh? Why? Generally guess. Where have you heard the name Mount Fuji before? Sorry? जापान में है. हाँ, किस चीज के लिए फेमस है? अगर वो वोल्केनो होगा तो क्या वो फोल्ड माउंटेन हो सकता है? नहीं. वोल्केनिज्म का प्रोसेस अलग होता है, फोल्डिंग का प्रोसेस क्लियरली अलग होता है. So clearly a mountain which is very famous for being a volcano cannot possibly be a fold mountain. Okay, so the guess is right. The instinct is correct. The answer is Mount Fuji. Mount Fuji is famously known to be a volcanic mountain, a dormant one, and clearly Alps, Andes, Rockies जो है वो हिमालयाज के साथ में अल्पाइन ओरिजिनी का पार्ट है, तो क्लियरली वो they are all fold mountains. Okay, ठीक है. Question 58. Which one of the following statements is correct? Hypocenter is the point on the surface of the earth nearest to the focus. Velocity of earthquake waves is higher in denser materials, and P waves move faster and the first to arrive at the surface of the earth. First statement consider करते हैं. Hypocenter is the point on the surface of the earth nearest to the focus. इसको सीधे समझ कर चलिए आप. इस पॉइंट को क्या बुलाएंगे? एपिसेंटर. थैंक यू. इस पॉइंट को एपिसेंटर बुलाते हैं. फोकस का दूसरा नाम क्या है? हाइपोसेंटर. डज द फर्स्ट स्टेटमेंट होल्ड ट्रू? नो. हाइपोसेंटर इज अ पॉइंट ऑन द सर्फेस ऑफ द अर्थ. हाइपोसेंटर एक तो अर्थ के ऊपर का पॉइंट नहीं हो सकता है. एपिसेंटर इज द पॉइंट ऑन द अर्थ which is nearest to the focus. Hypocenter and focus are the same. Okay, they are the same points. Velocity of earthquake waves is higher in denser materials. This you have to know. There cannot be a guess here. बिकॉज नॉर्मली डेंसिटी इंपीड करती है स्पीड लाइट के वेव को, लेकिन यहाँ पर उल्टा होता है. साइस्मिक वेव्स इनफैक्ट वो ज्यादा इलास्टिक मटेरियल मिलता है तो ज्यादा खुशी से आगे दौड़ते हैं. ओके, सो वेलोसिटी ऑफ अर्थक्वेक वेव्स हायर ही होते हैं डेंसर मटेरियल में. ओके, then clearly third statement, P waves move faster and are the first to arrive at the surface of the earth. Yes, absolutely yes. P waves का speed fast होता है. Among all the seismic waves that you know, P waves clearly have a faster speed. Not just that, P waves are also the first to be released. Okay, the P waves are released first, then there is a proper lag, and then the secondary waves are released. Okay, so clearly P waves not only move, they're not only the primary waves and the first waves to be released, but they're also faster, making them the first one to reach the surface of the earth. Okay, do P waves cause all the vibrations or quaking of the earth that we feel? Is it the P waves that make that happen? Which waves cause the surface waves? Absolutely. Surface waves make it happen. The P waves and S waves go and interact with the rocks of the crust of the earth, and clearly then the surface waves are set up, and that's how the earth vibrates, okay, या shakes. So इसका आंसर क्या होना चाहिए था? 2 and 3, है ना? D, 2 and 3 should have been the answer. Correct ही पूछ रहे, correct ही पूछ रहे. Good. Be careful ना, कभी कभी वो incorrect statements भी पूछते रहते हैं. Can you make this out? Yeah, you can. Which one of the following statements about earthquake waves is not correct? P waves move faster. They are the first to arrive at the surface. See, यहाँ पे आपको incorrect statement बताना है. P waves can travel through gaseous, liquid, and solid materials. Seismographs located beyond 145 degrees from the epicenter can record the arrival of P waves, and P waves have maximum area covered under its shadow zone. चलो first statement consider करते. P waves move faster. They are the first to arrive. Yes, absolutely yes, 100% yes. Okay. P waves can travel through gaseous, solid, liquid. Yeah, they're the only waves. Secondary waves cannot do that. Love waves cannot do that, and neither can Rayleigh waves. Only these waves can do this, okay? Only P waves can travel through all three mediums, and they are the only ones that are longitudinal in nature. The rest of them are transverse. Remember, P waves contrast with the rest of the waves in every which way possible, okay? Seismographs located beyond 145 degrees from the epicenter can record the arrival of P waves. Yeah, why? Because the shadow zone of P waves is only from 105 degrees to 145 degrees. Beyond that, of course, the P waves can be recorded. Okay. P waves have maximum area uncovered under its shadow zone. No, it is not. So this is your answer. Answer D is going to be your answer. This statement is incorrect. S waves have the maximum area under the shadow zone. Anywhere from the point of focus 105 degrees onwards, you will have all shadow zone for the S waves. Okay. This we have done. हमने प्लेट्स पहले कवर किए थे ना, प्लेट्स के ऊपर के क्वेश्चंस पहले कवर किए थे. ये भी कवर किया था ना? हाँ, कल ही किया था. ये वाला पॉइंट ऑफ ओरिजिन ऑफ अर्थक्वेक वेव इज नोन एज एपिसेंटर, फोकस, फोटोस्फीयर या साइस्मिक जोन. फोकस एब्सोल्युटली यस. फोकस जो होता है वहां से आपके अर्थक्वेक वेव्स जो होते हैं वो रिलीज होते हैं. अर्थ के सरफेस पे फर्स्ट टाइम कहाँ फील किए जाते हैं? वेयर डू यू फील देम फॉर द फर्स्ट टाइम ऑन द सरफेस ऑफ द अर्थ? एपिसेंटर. ओके. व्हाट इज अ फोटोस्फीयर? किस चीज से रिलेटेड है वो? सन से रिलेटेड होता है, राइट? द आउटरमोस्ट लेयर ऑफ द सन फ्रॉम विच ऑल द लाइट इज थ्रोन आउट is actually called as, from which light is emitted, is actually referred to as the photosphere. And what is the difference between the photosphere and the corona? These are things you really should know. This is the reason why I'm bringing this up is because these things are mentioned somewhere in NCERT textbooks, maybe in lower grades, but they are mentioned there, and UPSC expects you to know these little details. Outermost surface of the atmosphere, जो outermost layer होता है atmosphere का, that is known as the corona. वहां से वो सारे solar winds वगैरह बाहर निकलते हैं, and वो contain भी नहीं किया जा सकता है. During eclipses, अगर आप annular eclipse देखते हो तो जो आपको वो whitish color का ring दिखाई देता है during an annular eclipse is actually the corona. Okay. Seismic zone. What is a seismic zone? Which is vulnerable to earthquakes, where you can expect seismic activity to happen, where you can expect earthquakes to happen, would be referred to as a seismic zone. Okay. All right. Consider the following statements referring to. Can you guys see the board properly? Can you read whatever is written on it? It doesn't shine or anything, I hope. Consider the following statements related to Richter scale. It was devised in 1935 by Charles F. Richter. It describes the quantity of energy released by a single earthquake. Richter scale has no upper limit. इसमें से कितने statements सही है? How many statements of these are correct? It was devised by Charles F. Richter in 1935. That is very true. Okay, the statement is correct. It describes the quantity of energy released. Yesterday we had contrasted 2-3 scales. Okay, we had taken into consideration the Mercalli scale, which was the very first scale to be introduced. After that, we went through and checked out the Richter scale, and then I tried explaining to you about the moment magnitude scale. Okay, so Mercalli scale जो होता है, when we talk about a Mercalli scale, it measures the intensity of an earthquake, how severe the earthquake was and how much damage it caused. Okay, so we are just looking at the damages. We are looking at observations made after the earthquake, based on which you can calculate the severity of the earthquake. Okay, okay. Whereas what does Richter scale do? What it does is it has a proper instrument called as a seismograph. Then it measures, with that it measures a proper reading of the seismic waves, that is the seismogram. Based on the amplitude magnitude of the wave, uska wo logarithmic scale pe it calculates what is going to be the magnitude of the earthquake. Okay, so there are two different things that are being measured. Mercalli scale measures the intensity or the severity of an earthquake, whereas Richter scale will measure the magnitude or energy released during an earthquake. Okay, so the magnitude of an earthquake or the strength of an earthquake or the energy released is measured in a Richter scale. Of course, it was devised by Charles Richter in 1935, and it uses a logarithmic scale to measure the to calculate the magnitude of the earthquake based on the amplitude of the wave. Okay, based on the amplitude of the waves released. And उसका जो range होता है, does it have an upper limit? No, it does not have an upper limit. We do not need to calculate the upper limit because we believe that with a 10 plus earthquake, anywhere nearing 10, the entire earth has a possibility of being completely split up, after which we do not need any instruments or anything. Earth will cease to exist as we know of it. Okay, okay, fine. So clearly it does not have an upper limit. Okay, is that clear? No upper limit. Are you guys following what I'm saying? Okay, you are. No problem. And what about the moment magnitude scale? It is the most accurate scale that we know of. It calculates the moment of the seismic moment of the how do you say, the fault actually. It is all based on the fault. वो जो fault होता है जिसके through जिसकी वजह से ये earthquake हो गया है, तो वो उसका seismic moment measure करता है, and उसके ऊपर based we calculate the strength of the earthquake, the amplitude of the earthquake. Okay, ठीक है, and it is considered a far more accurate scale than the Richter scale. Richter scale works best in the lower magnitudes, but if you have an earthquake, a really severe earthquake, which has a greater magnitude, then clearly you would have to prefer the moment magnitude scale. Okay, so most, in fact, whatever magnitudes you calculate today related to earthquakes are mostly moment magnitude scale. Okay, no Richter scale anymore. We'll go with all three statements are correct then over here. All right, all three statements would be correct. फोल्ड्स हमने पहले कर लिए थे ना, which planes are horizontal and all, ये कर लिया था हमने कि किसमें actual plane is found to be virtually horizontal. It's going to be the recumbent fold. Okay, focus plate भी हो गया था, ये बताइए. Question 109. Which of the following statements about the ring of fire is correct? It is a zone of convergence plate boundaries. It is an active seismic and volcanic zone. It is associated with deep trenches. Convergence plate boundaries hai, you have the Pacific plate. Okay, you have the Pacific plate, and then around it you have multiple convergent boundaries with the rest of the plates. So it is a zone of convergent plate boundaries. Okay, it is an active seismic and volcanic zone. Yes, we believe that almost 70 to 80% of the world's seismic and volcanic activity happens in this particular zone. Okay, it is associated with deep trenches. Yes, the world's deepest trench lies in that particular place. Okay, Mariana Trench with the Challenger Deep actually is associated with the Pacific Ring of Fire. Okay, the technical name for it is Circum-Pacific Belt. Please do not always refer to it as Pacific Ring of Fire. Circum-Pacific Belt is the actual technical name of it. Pacific Ring of Fire is just a sweet way to call it. Okay, that's not the technically correct name. We will go with all three options are correct. That's the answer. ये कर लिया था. Upfold in a rock. Yes. What is an upfold in a rock called? Anticline. Absolutely. Upfold in a rock is called as anticline. Good. That finishes off this particular chapter. Now we move on to rocks. See people, the general flow that has been so far is that we first studied the universe and earth in general. Okay, then we focused on the earth. We checked out the structure of the earth, the interior of the earth, and we looked at the various processes that build up the earth. Okay, so in that when we considered, geomorphic processes, that's what we generally term as geomorphic processes. Within that, we first checked out the endogenic processes. Endogenic meaning that the power to change the surface of the earth, or the force to change the surface of the earth, comes from within the earth. Okay, that we attributed to the convectional currents that are being set up in the mantle, and because the convectional currents are being set up, the plates move, and that is causing earthquakes, volcanic eruptions, orogeny, epirogeny. We considered all those four things. Okay, now we move on to exogenic forces. If we are looking at the rest of the geomorphic movements, then we move on to the exogenic forces. What were the exogenic movements? The ones that will change the surface of the earth based on external factors like erosion hoga, weathering hoga, denudation hota hai, deposition vagare. We are looking at these factors. All right. So within that, the first thing that we check out, if we are going to check out how rocks are going to be degraded or weathered or eroded, we need to study the rocks first. We need to study the crust first. Okay, and that is why the rocks first. All right. Okay. Clear so far? All right. What the rocks, the entire crust of the earth is composed of rock, okay? And we say that rock is an aggregate, rock is made up of minerals basically. You understand what minerals are? They are found, they can either be organic, they can be inorganic. They're definitely found in a natural, they're naturally occurring, and they have a proper orderly atomic structure होता है उसका, एक definite chemical composition होता है, and physical properties भी होती है, okay? That is what a general mineral is. Usually एक mineral से नहीं बनते हैं, sometimes there are multiple mineral groups or multiple minerals adding to the composition of the rock, okay? And ये जो composition होता है of various minerals within a rock, that is never ever constant. It will depend on multiple factors. Rock formation की multiple factors होते हैं जिसके ऊपर depend करेगा कि कौन से mineral groups मिलेंगे. You generally have an idea of, say you can pick say 4 mineral groups कि ये 4 mineral groups इस rock में definitely मिलते हैं, okay? But उसका जो percentage होगा या concentration होगा वो आप predict नहीं कर सकते, okay? That will depend on place to place. वो condition to condition depend करेगा, ठीक है? Usually feldspar and quartz जो होते हैं वो सबसे commonly found minerals होते हैं. See this, feldspar and quartz जो होते हैं, they are the most commonly found minerals in the rocks that we find. Okay, ये जो बाजू वाला टेबल है ये NCERT अच्छे से छाप के देता है फर्स्ट पेज पे इस चैप्टर के, ओके? एंड इसके ऊपर यूपीएससी आपको अक्सर क्वेश्चंस पूछता है. बाय हार्ट कर लीजिए. दिस इज माय एडवाइस टू यू. आई एम नॉट, दिस इज नॉट अ सजेशन. ये दिस इज अ प्रॉपर वार्निंग कि इस टेबल पे बाय हार्ट करना है, ये इन एलिमेंट्स को बाय हार्ट करना है. यू विल बी, यू शुड कंसीडर योरसेल्फ लकी इफ यूपीएससी जस्ट लेट्स यू ऑफ बाय आस्किंग कि व्हिच इज द मोस्ट मेजर मिनरल इन द क्रस्ट ऑफ द अर्थ. दैट यू कैन सी इट इज ऑक्सीजन, ओके? बाय वेट इट इज 46.6%. लेकिन कभी कभी वो आपको 4 मिनरल्स का ऑप्शंस देते हैं एंड बोलते हैं इन 4 मिनरल्स को अरेंज करो in the ascending or descending order of their occurrence in the earth's crust, okay? Then you need to know this table, ठीक है? तो इस टेबल को बाय हार्ट कर लीजिए. I mean this is not my doing, this is UPSC's doing, okay? So oxygen being the one that is found in the largest concentration by weight. After that you have silicon, then aluminium, then iron, then calcium, then sodium, potassium, magnesium, and then the rest, okay? बाकी जो होंगे वो. लेकिन ऑक्सीजन सबसे बड़ा. Within the crust अगर आप देखें तो the mineral that is most found is oxygen. अगर पूरे earth को consider करें तो if we consider the earth as a whole, which mineral do you think will find the most or element? Ferrous. Who said ferrous? You said ferrous. Iron. Absolutely. Iron सबसे ज्यादा मिलता है. Okay? Iron is found the most. Sorry. यार एक और डेफिनेशन जान लीजिएगा पेट्रोलॉजी का. पेट्रोलॉजी जो होता है दैट इज स्पेक्ट्रा मीनिंग रॉक. तो पेट्रोलॉजी इज द स्टडी ऑफ रॉक्स, द साइंस ऑफ रॉक्स. तो फिर आप उसमें रॉक्स का सब कुछ पढ़ते हैं. मिनरल कॉम्पोजिशन क्या होता है, टेक्सचर क्या होता है, यू नो, डू दे हैव अ सॉफ्ट ग्लासी टेक्सचर और डू दे हैव अ ग्रेनी रफ टेक्सचर, स्ट्रक्चर कैसा है, लेयर्ड है, ग्रेनी है, क्रिस्टलाइज्ड है, ओरिजिन कहाँ से होता है, केमिकल ऑर्गेनिक ओरिजिन है या यू नो जस्ट मैकेनिकल ओरिजिन है, अकरेंस कहाँ होता है, वेयर डू यू फाइंड देम मोस्टली, मरीन एरियाज में, जनरली कहीं टेम्परेट रीजन्स में, ह्यूमिड रीजन्स में, वो भी ऑल्टरेशन कैसे होता है, अगर रॉक्स चेंज हो गए, अगर उनका मेटामॉर्फोसिस हो गया तो किस तरह से होगा, एंड रिलेशनशिप विद अदर रॉक्स, ओके? ऑब्वियसली यू विल चेक दैट आल्सो. Ma'am, if you have a very important conversation going on, I'd advise you to continue that outside the classroom. No worries. These are the various mineral groups in the rocks that are found. Normally आपको feldspar, quartz and mica जो है वो हर rock में मिलता है. Whether it is igneous, sedimentary or metamorphic, you will find this mineral group, feldspar, quartz and mica, आपको हर rock group में मिल जाएगा. फिर igneous rock के जो famous mineral groups होते हैं वो pyroxene, amphiboles and olivine होता है. Olivine, remember, just it was the mantle was comprised of olivine. Okay, so clearly olivine वहाँ मिलता है हमको. Sedimentary रॉक्स में आपको क्ले, कैल्साइट, डोलोमाइट, जिप्सम एंड हेलाइट के मिनरल ग्रुप्स मिलते हैं. एंड मेटामॉर्फिक में you get calcite, hornblende, which is actually an amphibole, स्टोरोलाइट, कायनाइट, गार्नाइट, सिलिमनाइट, ग्रेफाइट. ये जो सारे प्रेशियस स्टोन्स के जो मिनरल्स होते हैं ना वो अक्सर आपको मेटामॉर्फिक रॉक्स में मिलते हैं. whichever great precious stones you find, those are mostly found in the those are mostly metamorphosis का ये होता है, इफेक्ट होता है वो. ओके, ठीक है? Is this clear? Now you move to the types of rocks. Okay, basically 3 types के rocks मिलते हैं: igneous, sedimentary and metamorphic. Okay, तो इसमें से we'll study each rock type, उसके properties study करेंगे, उसके कोई major applications हमको दिखते हैं या कुछ major चीजें मिलती है तो वो करेंगे. Okay, sorry, I'm doing this a lot in Hindi. Are you getting it? Are you following it? No. Which part did you not follow? Should I explain that again? अच्छा, that is okay. All right, I'll try to speak in English as much as possible. आपको जिनको किसी को हिंदी में एक्सप्लेनेशन चाहिए हाथ उठा लीजिए, मैं हिंदी में दोबारा एक्सप्लेन कर दूंगी. ओके, आई फील यू गाइस, सो इट्स ऑलराइट. We move on to igneous rocks first. Okay, igneous comes from the fact that they are made from molten lava, molten magma, molten rock से बनते हैं, lava से या magma से बनते हैं, इसलिए वो igneous rocks है. Okay, first things ever, these are the primary rocks, these are the basic rocks that ever existed. Okay, ये रॉक्स होते हैं एंड देन उसके ऊपर बेस्ड बाकी के रॉक्स होते हैं, लाइक इग्नियस से फिर सेडिमेंट्री बनेंगे, मेटामॉर्फिक बनेंगे, बट बेसिकली इग्नियस, इट इज द इग्नियस रॉक्स दैट एग्जिस्ट फर्स्ट एंड द रेस्ट लेटर. ओके, सो हाउ आर दीज फॉर्म्ड? These are formed by the cooling and solidification of either the lava on the surface of the earth or the magma beneath the surface of the earth. Okay, if the molten rock exists beneath the surface of the earth, we call that as magma. If it manages to come to the surface of the earth, we call that as lava. So cooling and solidification of lava or cooling and solidification of magma, in either case would give you igneous rocks. Okay, these rocks famously in their physical structure do not have layers or strata. Okay, sedimentary rocks are very famous for having layers and strata, right? But igneous rocks do not have any layers or strata. They are simply a sheet or a block of lava or magma which cools down in a while and crystallizes. Crystals होते हैं, grains बनते हैं उसमें. You can find grains inside there, you can find crystals inside there, mineral crystals, but clearly there are no layers. Okay, you have a question? Achha, okay, you did this. So clearly there are no layers over there. Okay, and clearly you will not find any fossils over there. Why not? Why not? Why no fossils? Because the lava is it is it's of extremely high temperature. The lava exists anywhere between 800 to 1200 degrees Celsius. Nothing can survive in that. Okay, nothing can survive in that heat, obviously. So clearly there is no possibility of having a fossil which can, later be found in the igneous rock. So fossils is not a thing for igneous rocks. Okay, hard and resistant in most climate and conditions. These rocks are extremely famous for being very hard, very resistant, and वो weathering भी उनका बहुत आराम से होता है. They are very resistant even to weathering, and they are also resistant to generally, they are also used as building blocks. Granite is very famously used as building blocks for the same reason that they are extremely resistant. They are very hard. Okay, and clearly the texture of the rocks is going to depend on the size and arrangement of the grains, mostly on how the rock is formed. Okay, if the rock is formed very quickly, if the lava gets to cool and solidify very quickly, then you will get a nice glassy structure. And if the lava is usually cooled beneath the surface of the earth, it takes a lot of time to cool and solidify, then the rock formation process is really complete and you will find larger grains. Okay, so that will, now what kind of grains you will find and what will be the texture of the rock will clearly depend on what the cooling process is going to be. All right, okay. The examples of these are granite, basalt, gabbro, pegmatite, volcanic breccia. इसके ऊपर जो questions आते हैं, the questions that are based on this are usually about having 4 options and being able to point out which of these is an igneous rock, which of these is a sedimentary one, or which is a metamorphic one. Okay, so usually such questions are asked. Sometimes they will question you based on this table, the table that is the adjacent table, but mostly the questions are simply that point out which of these is an igneous rock or which of these is a chemically formed sedimentary rock, something like that. Just identifying rocks. Most questions are about identifying rocks. Okay, now let's look at the classification of igneous rocks. Igneous rocks can be classified in 3 ways, one by texture, the other by composition, and lastly by origin. Okay, so by texture, meaning what sort of grains do you find? Do you find smaller grains or do you find larger grains? Okay, so if you're looking at fine grained rocks, then clearly they are found at the surface of the earth. See, what happens is, let's say there is a volcanic eruption, any kind of eruption, the lava does manage to come out and spreads on the surface of the rock. Okay, on the surface of the earth. Okay, what happens is it is immediately exposed to external elements like wind, water, rivers, oceans. Probably the eruption might have happened underneath the ocean floor. Okay, so clearly now it is exposed to the ocean. The first effect that the lava really feels when it comes out is being cooled down by the ocean water. Okay, so clearly whenever lava is exposed to the earth's surface, then clearly the cooling will happen very quickly. Okay, the very small in size. Okay, so it gives it a very polished glassy appearance. The rock that's so formed gets a very nice polished glassy appearance. Okay, so you call that as fine grained rocks. So prime example is going to be basalt. Okay, basalt is the one that makes up the entire Deccan Plateau. Okay, we are looking at that rock. The second kind is when the rock is properly coarse grained. Okay, now say the magma is raised beneath the surface of the earth. Okay, you have no external elements there. The heat is retained, and the magma takes a long time to cool and solidify. Okay, now the rock formation process or the grain formation process is actually complete, and the grains thus formed are large in size. Okay, they are nice, large in size, and this kind of rock usually is coarse grained, and the prime example for that is going to be granite. Okay, ठीक है, cool so far? Alright. Next classification जो होगा, that will be based on composition, meaning what it contains, which minerals it contains. Okay, so we are basically looking at whether the rocks will have a higher concentration of iron and magnesium, ferromagnesians, या फिर will they have a higher concentration of silica. Okay, so now let's say consider rocks which do have a higher concentration of iron and magnesium. Okay, such rocks are called as mafic rocks. Okay, they are called as basic rocks or mafic rocks. Remember these terms. UPSC का एक और favorite question होता है कि they pick out all these little words and question you on it. Okay, they love to do that. The reason why I kept repeating the lava flows yesterday was also because UPSC loves to pick out these words, different sounding, newly fangled words, and they keep asking you questions on that. Okay, so basic rocks or mafic rocks are those that have a higher concentration of iron and magnesium. Okay, and because of the presence of iron and magnesium, clearly they are a little darker in color also. Because of the presence of those minerals, the rocks usually happen to be a little darker. Okay, prime example being basalt and gabbro. Okay, those are those two rocks that are really basic in nature. The next kind of rock is clearly acidic, the one that will not have a higher concentration of iron and magnesium, but instead it will have a higher concentration of silica. Silica ज़्यादा होता है, sand जिससे बनता है वो silica ज़्यादा होता है. Okay, so higher proportion of silica we call that as felsic. Okay, and because silica is not very dark colored, clearly the rock so formed is also light colored. Okay, prime example granite. All right, ठीक है. By the origin, on the basis of origin, अगर classifications are now igneous rocks का, so we will have to figure out if the rocks are formed above the surface of the earth or below the surface of the earth. Okay, if the rocks are formed above the surface of the earth, उनको volcanic या extrusive बुलाते हैं. Okay, they are called as volcanic or extrusive. जल्दी से बनते हैं वो rocks, rapid cooling and solidification हो जाता है. And smaller crystals, usually they have smaller crystals, glassy appearance. The examples being basalt, pumice, tuff वगैरह. Pumice का पत्थर पता है आपको कैसा दिखता है? Have you ever इनके पास दिख रहा है क्या pumice कहीं? Pumice is something you must have seen. आपने definitely देखा है pumice कहीं ना कहीं. How have you not? No, I don't need to know what. You see this rock? You've seen this rock, right? This is a very common rock. घरों में मिलता है. उससे एड़िया घिसते हैं. नहीं, आपके घर में नहीं मिलता है. एड़िया घिसने के लिए होता है ये rock, हर किसी के घर में होता है, right? You're supposed to clean your heels with that. With this particular rock, in Indian households, at least in the households that I know of, people use this rock to clean your heels, right? You use this rock. It's a very famous rock. It does not hurt. It has a pretty glassy appearance and it is smoother. It's quite smooth, okay? But it cleans. It definitely cleans the heels. No, this, okay? So that is volcanic or extrusive rocks. Those rocks are called as volcanic or extrusive. Then of course we will consider the rocks that are formed below the surface of the earth, okay? Those are called as plutonic rocks. Remember yesterday's terminology, I had told you that Pluto is known to be the god of underworld. I don't remember which mythology, okay? But Pluto is the deity or the lord of the underworld. So anything below the surface of the earth is referred to as plutonic. हम उसको plutonic करके refer करते हैं, okay? So plutonic would be those rocks which are formed beneath the surface of the earth. Intrusive rocks होते हैं. Clearly, it takes a long time to cool and solidify. Hence, the grain size formed is proper, larger, and the rocks are nicely well formed. Okay, they're also far more resistant than maybe the volcanic rocks. Okay, so this is granite, gabbro, diorite. These are those rocks. All right. This is a general idea of what it looks like. See, they are showing pumice over here also. It looks a little different from what I've seen. And clearly volcanic ash. This would also be considered as rock. People, volcanic ash would also be considered as rock, and so would pumice. See, उन्होंने mafic and felsic का different ये दिया है कि basalt मिलेगा आपको या gabbro मिलेगा in mafic rocks and rhyolite या granite. Okay, so these are felsic. Clearly you can see basalt and gabbro are a little dark colored, and rhyolite and granite are clearly light colored because of the presence of silica. Okay, ये porphyry को explain करते हैं. नीचे वो porphyry नजर आ रहा है. Porphyry मतलब it is neither completely small grained, neither completely large grained. Okay, what you will see is that in a rock which is mostly full of small grain material. Okay, basalt जैसा कोई rock होता है ना, जिसमें where you find smaller grains, उसमें कहीं कहीं आपको बड़े बड़े पेनोक्रस्ट जो होते हैं, बड़े बड़े क्रिस्टल्स या बड़े बड़े साइज के ग्रेन्स जो होते हैं, they are embedded within that rock. Okay, you will find larger grains in a mostly small grain rock. Okay, so such rocks are called as porphyry. Such rocks we call as porphyry. Okay, this is once again an igneous rocks related term, so we'll remember it the way it is. Okay, people, are we good here? Igneous rocks is done. Now we move on to sedimentary rocks. Sediment का मतलब क्या होता है? What is sediment? Something that settles, right? Something that settles. Something that settles, something that is left behind, that is going to be sedimental. So obviously sedimentary rocks are those that are formed of this sediment. Okay, sedimentary rocks are usually formed from remains or debris or something like that. Okay, it is usually formed from leftover materials of something else. All right, that is what usually sedimentary rocks are. So we say that sedimentary rocks are formed from broken fragments of various rocks, organic matter, etc., which are usually transported by transporting agents like rivers, glaciers, winds, even animals. Okay, so anything that will transport material from one place to another is capable of transferring these sediments, and all these sediments are usually brought in one place and accumulated. Okay, now what happens is, say suppose something happened and some sediments are left behind. Okay, then these transporting agents like winds, glaciers, etc., bring in more material and it there again. Okay, now there is more sediment, there is an accumulation of a larger sediment. Okay, clearly the lower layer over which this sediment settles, let's say this is accumulated layer by layer. Okay, clearly the upper layers will exhibit some kind of pressure, will exert some kind of pressure on the lower layers. Okay, so because of that, because of the overlying pressure, the lower layer gets compressed. Okay, it gets compressed and it gets solidified. Okay, वो properly compress हो जाता है, compact हो जाता है, solidify हो जाता है. This process is called as lithification. Okay, this is an important term. UPSC is there to ask you this once, so please pay attention. Once again, processes and terms जो sound करती है ना, जैसे porphyry था, lithification था, Nui Ardan था, तो we are saying we are paying attention to these terms. Okay, so what happens is the upper layers, as and how the deposits of the sediments keep on accumulating, the lower layers keep getting compressed by the pressure, overlying pressure, and because of that, the lower layer keeps getting compacted, okay, and getting formed into proper rocks. This process is called as lithification, and that is how this layered structure comes to be. Usually, one layer is derived from a certain kind of material, okay, from say certain kind of animals, a certain kind of rocks or something like that. Okay, the next layer does not have to be similar to the first layer. Okay, the next layer can be derived from different kind of materials. It can have a different accumulation. So clearly, the layers do not have to be similar to each other, and that is why you can clearly see in this picture. Can you see that there is a clear distinction of color and everything in the picture? Yeah, you can make out, right, that these layers are very different. Sedimentary rocks are famous for these, for being extremely varied. One layer does not have to match either its physical or chemical properties with the next layer. Okay, clearly they do not match. जरूरी नहीं होता है. They can match, they may match, but it is not necessary that it matches. Okay, okay, it's a properly layered stratified structure. Sedimentary rocks are extremely famous for having proper layered structures. Okay, and these layers will retain the characteristics despite the rock being fully formed. So it is quite possible that if you have a sedimentary rock over here, okay, so these layers can be alternately hard and soft. Okay, it is not necessary that the entire rock has to be hard. Granite may, if you consider granite, it is the rock as a block. Okay, so that entire rock is going to be extremely hard. In case of a sedimentary rock, it is quite possible that different layers can retain different characteristics. A layer can be hard, the next layer can be soft, then another layer can be hard, the next layer can be soft again. So clearly they will retain different characteristics, both physically as well as chemically. Okay, because that will depend on wherever they source the material for the layer from, and the layer for the material can come from different places. All right, okay. They are usually non-crystalline in nature. Very rarely do you find crystalline form of sedimentary rocks, and they often contain fossils. This is one of the biggest and most important economic importance of sedimentary rocks, that they do contain fossils, right? They may be carbonaceous in nature, so they will transform into coal and stuff like that. Or then you can find them somewhere near marine deposits, and that can transform easily into natural gas and petroleum and stuff like that. Okay, huge commercial importance for carrying these fossils. So we are going to derive all those fossils, all those how do you say, what do you call that? Fossil fuels from these rocks, from the sedimentary rocks. Okay, they can be either hard, they can be soft. These rocks are extremely varied in nature. In fact, they're the most varied of all rocks. Igneous rocks में आपको 4 types मिलते हैं, metamorphic में भी 10 मिलेंगे, but sedimentary are the most varied of all the rocks that you find. ठीक है? Is this fast for you? Can you follow this? Yes, you can. If you do not follow it, please tell me. I will try to slow down, or I'll try to repeat whatever I'm saying. Okay. Next is we look into the classification of sedimentary rocks. Like we have looked into classification of igneous rocks, clearly we'll be looking into the classification of sedimentary rocks as well. Sedimentary rocks can be formed in three ways. Either they can be mechanically formed, or then chemically formed, or organically formed. Okay, we are looking into three ways. So mechanically formed one is mechanical. जैसे मैंने the way we described at the very beginning that sediments are acquired from different places, they are accumulated and then they settle. Okay, and the sediments lying above will exert pressure on the sediments lying below, and they will try to compact the rock as much as possible. Okay, so these cemented accumulations of materials derived from other rocks, that is how mechanically formed rocks are. Sedimentary rocks. The texture, composition, color will vary tremendously because once again the material is sourced from very different places. Okay, for example, the prime example being sandstone. वो sand के जो grains होते हैं, whatever sand grains are found, those come together, they are compacted together, and sandstone is formed. Okay, conglomerate is one rock which is formed from larger rounded pebbles. Okay, ये दिख रहा है आपको? Can you make out the conglomerate and the angular breccia, the breccia? Huh? This is conglomerate, this is breccia. What conglomerate does it has rounded class. Okay, it has the rounded pieces of rock which are cemented together, and that gives it that roundish structure. Okay, smoothish roundish structure मिलता है उसको for conglomerates. Whereas breccia, you can see they are angular, नुकीले है, right? Oh, they are little angular class, and those are cemented together, and they form the breccia. Okay, that is how breccia is formed. You have clay. Clay is formed from finer sedimentary materials. Clay rock to pata hai, we know clay, right? And clearly shale, mudstone, sand, gravel, these will also be considered as sedimentary rocks which are mechanically formed. Okay, these are mechanically formed sedimentary rocks. Look at the organically formed sedimentary rocks. Organically meaning what? Now it has to come from either plant or animal origin, right? Organic has to be that the origin can either be plant or the origin can be animal. All right. So these are formed. These rocks are formed by the remains of the living organisms. Okay. Usually, what is left behind of those animals is gets decomposed and transforms itself into animal origin. We call this calcareous because it is mostly made up of skeletons. Okay, skeletons of the animals left behind. It is made up of that. Those are cemented together, and that is how these rocks are formed. So, people at the back change places. People sitting at the very अच्छा कौन सी लैंग्वेज बेहतर समझती है? लास्ट रो, जो भी लास्ट रो में बैठे सामने आकर बैठ जाइए, बाहर जाकर बैठिए, आई डोंट माइंड. ठीक है. So, like we discussed, it can either be of carbonaceous origin or calcareous origin. Okay, तो carbonaceous origin में क्या होता है? Clearly, वो जो rocks होते हैं, वो vegetative matter से बनते हैं, plants होते हैं, which get fossilized, वो fossilized हो जाते हैं उस पूरे cementing में, and then those will later have greater economic importance. We have already seen कि हम coal, kerosene नहीं, petroleum and natural gas are extremely important for us. So these are greater economic importance. Okay. Examples of that are peat, lignite, and coal. Let's look at the calcareous things. What happens is there are animals, especially marine organisms, that have very hard shells. Okay, उनके जो shells होते हैं, they are pretty hard, and then there is obviously soft flesh embedded within this shell. Okay, or protected by the shell. Now, what happens? Let's say when an animal dies, the soft shell decomposes. Okay, वो जो soft flesh होता है, that is decomposed very quickly. But the hard shells are left behind. The bones or the skeleton is left behind, and then multiples of these are usually brought together, cemented together, and uska banta hai ek rock. Okay, that rock is usually a calcareous rock, like say limestone or chalk. Okay, so that is the origin of organically formed calcareous rocks. All right, ठीक है, चलिए. Next rock, next type is chemically formed. Chemically formed rocks are usually by, see, there are whatever sort of biochemical reactions happen or chemical reactions happen, So sometimes residue of that is left behind. Okay, the sediment or residue of that is left behind, and what is left behind is usually then hardened out into a rock. Okay, in case of say rock salts, for example. So for example, when playas or in deserts or something, when the lakes or seas dry up, okay, water bodies dry up, what is left behind is because of that extreme evaporation, a lot of salt is left behind, and that entire salt pan or the entire salt bed is left behind. Okay, so rock salts are usually derived from that. Then you obviously have gypsum or calcium sulfate that is derived from the evaporation of salt lakes. Salt lakes usually give that. There is another way. Yesterday we had seen geysers, right? I had told you what geysers are. We had said that it's a fountain sort of a thing of superheated steam and superheated gas and water coming out, minerals and all coming out. Okay, so usually what happens in geysers when this thing all comes out, it is usually left around, right? Sometimes closer to where the geyser is, it is left over there. And when the material accumulates over there, the water evaporates. What is left behind is a rock called as geyserite. Okay, so once again, that would be a chemically formed sedimentary rock. Potassium nitrates, once again, prime examples of that. Chert is also a very prime example of chemically formed sedimentary rock. Okay. Once again, please remember, like I said in this chapter, the one thing that UPSC tends to ask you is give you 4 options, ask you which of these are chemically formed, mechanically formed, which of these are a sedimentary rock or an igneous rock or a metamorphic rock. Very, very happy question for UPSC. Okay. So pay attention to the various rock types, pay attention to the various names of the rocks, and remember which type belongs to which category. Okay. Which rock belongs to which category is really important. You can see how sandstone is very fine grained, right? You can see it is clearly made up of sand and everything. And back is another different rock over here. Mudstone clearly दिखता है ज़्यादा fine grained है. Mudstone is a little more fine grained. Shale is also pretty fine. It is fissile. इसको वो layers भी break कर सकता है. Coal is how this looks like. Rock salt we have already seen. This is limestone generally, which is a calcareous rock, and then this would be iron ore. Okay, once again important sedimentary rock. The last of this is going to be metamorphic rocks. Okay. Meta means change, morph means form. Okay, form या जो appearance है, composition है, वो that is form. Okay, so metamorphic means the form is changed. The rock changes itself. Okay, why? Because of say maybe application of pressure, volume, temperature changes. Okay, that is what is happening. So you say originally there was one rock. It could be igneous, it could be sedimentary, it could be metamorphic. Okay, it is subject to pressure, temperature, and volume changes, and because of that, the crystals, the rock changes itself chemically and physically, and transforms itself into a completely different rock. Okay, the process takes a lot of time, and clearly, it depends on what kind of what is really causing the change, whether it's just the pressure change or it is a tremendous amount of heat is also involved. Clearly, that will make a difference. But this is how metamorphism works. Okay, one rock, whether it is igneous, metamorphic, or sedimentary, it completely changes by the application of heat, pressure, and volume changes. And because of that, it will transform its chemical as well as physical properties. Sometimes it does not transform the chemical properties as much, but it does do that. वो crystals खुद को reorganize कर लेते हैं, reorder कर लेते हैं, readjust कर लेते हैं, and एक different type का rock बन जाता है. Okay, a wholly different rock is formed, which has very different properties from the original rock. Okay, ठीक है? That is what metamorphism is. तो मेटामॉर्फिज्म के प्रोसेस में ऑलरेडी कंसोलिडेटेड रॉक्स जो होते हैं दे अंडरगो रिक्रिस्टलाइजेशन एंड रीऑर्गेनाइजेशन विद इन द ओरिजिनल रॉक एंड अ होल न्यू डिफरेंट रॉक इज फॉर्म. ओके, मेटामॉर्फिज्म के दो टाइप्स होते हैं, एक डायनामिक एंड एक थर्मल मेटामॉर्फिज्म. डायनामिक माने क्या? प्रेशर चेंजेस. ओके, वी आर क्लियरली लुकिंग एट प्रेशर चेंजेस. वी आर सेइंग मैकेनिकल डिसरप्शन होगा, रीऑर्गेनाइजेशन होगा विदाउट एप्रिशिएबल केमिकल चेंजेस. यूजुअली डायनामिक मेटामॉर्फिज्म में वेरी लिटिल टू नो अमाउंट ऑफ हीट इज इन्वॉल्व्ड. ओके, यूजुअली हीट इन्वॉल्व नहीं होती है in dynamic metamorphism. Please remember this. Okay, for example, there is a fault. ओके, एक कल मैंने सैन एंड्रियास फॉल्ट देखा था ना, वो काफी बड़ा फॉल्ट है, लेकिन इमेजिन अ स्मॉलर फॉल्ट ऑफ अ स्मॉलर मैग्नीट्यूड. ओके, सो देयर इज अ फॉल्ट. तो उस फॉल्ट के अलोंग जो चेंजेस हो रहे हैं, जो स्ट्रेसेस सेटअप हो गए बिकॉज ऑफ द टेंशनल फोर्सेस, तो दैट इज यूजुअली अ केस फॉर डायनामिक मेटामॉर्फिज्म. ओके, दैट इज अ वेरी गुड केस फॉर डायनामिक मेटामॉर्फिज्म. छोटे से एरिया पे होगा, द फॉल्ट हैज अ स्मॉलर एरिया आल्सो क्लियरली, एंड द pressure changes are appreciable enough to change the rock to some extent. So clearly, and no heat is involved, right? There is very little application of heat over there ना, कोई volcano नहीं है, कोई major bending warping वगैरह नहीं हो रहा है, तो clearly the heat involved is less. Okay, so chemical changes नहीं होंगे, लेकिन physical changes बहुत हो जाएंगे उस rock में. Okay, उसके physical properties बहुत alter होंगे. So that would be dynamic metamorphism. थर्मल मेटामॉर्फिज्म में क्लियरली हीट इज इन्वॉल्व. ओके, थर्मल बुलाया है, उसका नाम बोला है थर्मल है करके, सो क्लियरली नाउ अ ह्यूज अमाउंट ऑफ हीट विल बी इन्वॉल्व. ओके, सो इसमें क्या होता है, मटेरियल्स जो होते हैं रॉक के वो कंप्लीटली रिक्रिस्टलाइज हो जाते हैं बिकॉज ऑफ द प्रेजेंस ऑफ हीट एंड प्रेशर. वो कंप्लीटली रिक्रिस्टलाइज हो जाते हैं एंड दे चेंज देमसेल्व्स, रीऑर्गेनाइज देमसेल्व्स एंड बिकम अ होली डिफरेंट रॉक. ओके, अब थर्मल मेटामॉर्फिज्म के दो टाइप्स होते हैं, एक तो कॉन्टैक्ट मेटामॉर्फिज्म होता है, दूसरा रीजनल मेटामॉर्फिज्म होता है. कॉन्टैक्ट मीनिंग सेज देयर इज अ रॉक. ओके, देयर इज अ बेड ऑफ रॉक समवेयर. ओके, एंड यहाँ पर कहीं अपना कोई मैग्मा चेंबर है. ओके, करीब में कोई मैग्मा चेंबर है, तो क्लियरली वो मैग्मा चेंबर की जो हीट होती है, द हीट फ्रॉम दैट मैग्मा चेंबर इज गोइंग टू अफेक्ट दिस एंटायर बेड ऑफ रॉक. ओके, एंड the amount of rock or the quantity of rock that is in contact with this particular magma chamber is going to show that effect. Okay, it is going to alter, it is going to metamorph, size and clearly change. Okay, वो change हो जाएगा. That is contact metamorphism. Okay, high temperatures में, under very high temperatures usually they come in contact with hot magma or lava. Even if there is a lava flow, let's say कि वो magma chamber से थोड़ा सा दूर बैठा है, yeah, then the magma is actually, the rock actually has access to magma. The magma actually reaches the rock. Even then the rock will melt, recrystallize and form itself into a whole different rock. Okay, that is contact metamorphism. And then there is regional metamorphism. The girl behind you. Okay, this is enough. Regional metamorphism में क्या हो जाता है कि usually we are considering, the reminder is that your friend's expressions change. You come and sit in the front. Rather than being so crowded over there like a fish market, come and sit ahead. Come here. I fail to understand why you even sit in the classroom if you're not listening. Don't you have better places to be? Places to learn. If you're not sleeping and generally talking, I understand if you're catching up on sleep. See, he's being a nice guy. He's catching up on his sleep, right? That is okay. He will be fresh for the next lecture. I don't understand why people keep on talking while sitting here. Doesn't make any sense to me, actually. There are 100 teachers in this building who can teach you any subject you want at your fingertips. You have that. Why don't you sit in a lecture where the teacher will you actually listen to the teacher and you learn something within that time? Okay, then we are at regional metamorphism. Okay, regional metamorphism में क्या होता है? Clearly you are talking of an entire region. So here we are talking of a phenomenon like folding. Okay, orogeny में जो folding होता है, we are talking of something like that. Okay, so folding में क्या हो जाता है people? Regional metamorphism में, say for example the Himalayas. While the Himalayas are being formed, clearly the rocks, compressional forces are acting. The rocks are being folded. Okay, properly वो जो crust है, that is being folded, and because of that there is a huge deformation of the rocks. Okay, because of the involved high temperature and pressure, बहुत ज़्यादा pressure involved है, बहुत ज़्यादा temperature बढ़ जाता है, and clearly उसमें जो rocks का reorganization, recrystallization हो जाएगा, that will be regional metamorphism. Okay, do you understand the difference between thermal and dynamic metamorphism? Dynamic metamorphism is for a smaller area. Thermal metamorphism usually involves larger areas and most definitely involves heat. Okay, heat and temperature definitely involved होते हैं. In case of dynamic metamorphism, you do not have the participation of heat. Heat ज़्यादा participate नहीं करता है. Okay. Okay. अभी metamorphic rocks के दो important qualities study करते हैं. Two very important properties. One is foliation or lineation. The other is banding. Folio in Latin, I think it means a leaf. Okay. So foliation या lineation मतलब metamorphic rock में, within the metamorphic rock you can see lines. Okay. Can you make out lines over here? The darker lines in the first rock in foliation, right? There are darker lines over there. You can clearly see the darker lines as opposed to the rest of the rock. Okay. In banding, you can clearly see that you have alternate light and dark colored bands, right? There are proper bands of light and dark colored material. All right. So now clearly foliation happens when within the metamorphic rock there is at least one dominant mineral that is going to behave a little differently from the rest of the minerals. Okay, so we are talking of one dominant mineral which is behaving differently. What happens is when foliation happens, usually the pressure is applied very differently from very different sides with very varying intensity and regularity. बहुत अलग अलग तरीके से pressure apply होता है, and एक single mineral जो होता है उसमें से one single mineral out of this decides to behave completely out of fact. Okay, what it does is it tries to align itself perpendicularly to the direction of the stress. अगर direction of stress ऐसा होगा, the mineral will try to align itself in this fashion. Okay, so what happens is this single mineral, that is just how the mineral naturally behaves. Okay, that is the natural behavior of the mineral. So this mineral tries to align itself in a different way when the stress is applied. So usually, first of all, you need that dominant mineral over here, and only then this can happen. And the stress has to be applied in a very different fashion. Okay, it has to be applied with not enough regularity, with with high intensity stress apply hona chahiye. Clearly the stress has to be applied in very different directions, various directions. tab jaake finally ye minerals aise align ho jate hain ki they are perpendicular to the stress, they align themselves perpendicular to the direction of the stress and get arranged into single lines. Okay, they get arranged into single lines, as you can see over here in foliation. Okay, that is foliation. That is all that foliation is for you. Remember, one single dominant mineral. Okay, look at banding. Clearly, you can see there are light colored bands, dark colored bands, adjacent, opposite, like you can see alternate light and dark colored bands. Okay. Now, clearly in banding, there are two important minerals involved, two dominant minerals involved, because one has to be light in color, the other has to be dark in color. Okay. Now, what happens over here is the minerals don't just arrange and align themselves. Okay, they change themselves. They are reorganized, recrystallized, and reordered up and down. Okay, so that they are grouped together. All right, because the pressure, applied pressure, is so much that the minerals change themselves, reorganize, recrystallize themselves, and go and stick to whichever is their similar mineral. Okay, so light colored bands start appearing, light and dark colored adjacent bands start appearing. Okay, so this is the essential. This is the process for banding. Okay, तो banding के लिए क्या समझा आपको? कम से कम minimum at least two dominant minerals have to exist, ones that are going to be reorganized and reordered in such a way that they can form light and dark colored bands. And this is how, and obviously you will have to, the rock has to work under extreme pressure. Okay, so this banding is a very standard quality for gneiss. Gneiss rock पता है आपको? gneiss, GNIEISS, हाँ, ग्रेनाइट का जो मेटामॉर्फिक फॉर्म है, नाइस, हाँ, तो उसका ये बहुत स्टैंडर्ड क्वालिटी है बैंडिंग. इट्स स्पेक्टाकुलर, द बैंडिंग इज स्पेक्टाकुलर एंड नाइस. ओके, ठीक है. Am I missing something? No. The examples for all these rocks are gneiss, marble, schist. Okay, the next table has to be array. ये देख लीजिएगा. I told you, right, that whichever major, precious stones you find, they are mostly metamorphic in nature. Okay, आप जितने भी major precious stones जानते हो, kyanite, sterlite वगैरह, वो सारे metamorphic होते हैं nature में. वैसे ही एक lapis lazuli भी मिलता है आपको, history में भी इसका reference मिलेगा. अफगानिस्तान में मिलता है, मोहनजोदारो used to deal in it, they used to trade in it. That was the IVC trade, right? So we are looking at that. lapis lazuli देख रहे हैं. Anthracite famous है, coal का भी वो carbon का metamorphic form है वो. And this is generally how metamorphosis progresses. Okay, steel to slate to phyllite to schist to gneiss. Okay, so the more and more you try to, the more and more pressure is applied, the more temperature is applied, the more the probability of the rock being further metamorphosed. Okay, ठीक है. This table has to be learned by heart, really by heart. Okay, this is metamorphic rock in its original form, and then that will depend on whether it's igneous or sedimentary or original metamorphic form. But it changes you have to remember which metamorphic form it's going to change itself into. Okay, so granite is an igneous rock, it changes into gneiss. Okay, clay is a sedimentary rock, it changes into slate, it gets metamorphosed into slate. Shale is again a sedimentary rock, it will change into schist. Okay, limestone is a sedimentary rock, organically formed sedimentary rock, it will metamorphose into marble. Sandstone, again a sedimentary rock, it will metamorphose into quartzite. And coal, again a sedimentary rock, it will metamorphose into graphite. Okay, clear? Will you remember this table? And then the last part of it is a rock cycle. Okay, rock cycle meaning rocks do not always remain in the way they are. Okay, they will keep changing. They are always undergoing the process of transformation, either due to weathering or erosion, or then due to such changes like igneous rock changing to sedimentary, because they are crumbling, they are breaking down. Clearly, an igneous rock can contribute to the formation of a sedimentary rock or something like that. So clearly, rocks are always in a state of changing, and they do not remain the way they are for a long period of time. Okay, so this process of continuous change of the rocks and their transformation is called as the rock cycle. We are saying that original rocks, the very first original rocks, are going to be primary rocks. Okay, those are the igneous rocks. All right. Now these igneous rocks can remain igneous for their lifetime, or they can break down and contribute to form a sedimentary rock, or they can undergo tremendous amount of changes in pressure and temperature and metamorphose into a metamorphic rock. Okay, they can change or transform into a metamorphic rock. Okay, sedimentary rocks का क्या हो सकता है? Once again, if they come into contact with lava, they can completely melt and recrystallize and reorganize themselves into an igneous rock, or they can break down. Sedimentary rocks themselves can break down and form further sedimentary rocks. They can contribute to being more sedimentary rocks, and then of course they can undergo pressure and temperature changes and change into metamorphic rocks. Metamorphic rocks का भी वही है. If metamorphic rocks come into contact with lava or magma, they can melt and change into igneous rocks, or they can break down, crumble completely, and contribute to sedimentary rocks, or they can be further metamorphosed. Okay, you know, right? A metamorphic rock can also go further metamorphosis, and it can be further metamorphosed. Okay, so we are saying that can happen. This is the rock cycle. Are we done here, people? Do you wish to take a 5-minute break? I will begin the lecture at exactly 16 minutes past 3. And you are 12th and 12th class together? saying something? No. आप कुछ बोल रहे थे ना? Finish. How many of you have studied in the ICSE board? You have? Does this look similar to whatever you read in geography? It is, right? सिर्फ एनसीईआरटी नहीं चलेगा, आईसीएसई बुक्स भी पढ़ना शुरू कर दीजिए, because they are deriving questions, at least the ones based on rocks and everything from there. The language reads similar. You have to understand if UPSC is sourcing their questions from a certain book. If they are, if the questions are being sourced from that book, you need to read that book pronto. Okay? ठीक है? Here we are. So the first question, consider the following statements with reference to feldspar mineral. Okay? फेल्सपार के बारे में बात कर रहे हैं, मिनरल ग्रुप है तो उसके बारे में बात कर रहे हैं. वी आर सेइंग कि हाफ ऑफ द अर्थ्स क्रस्ट इज कंपोज्ड ऑफ फेल्सपार. इट हैज लाइट क्रीम टू सामन पिंक कलर. मैग्नीशियम इज अ कॉमन एलिमेंट इन ऑल टाइप्स ऑफ फेल्सपार. इसमें से कौन से स्टेटमेंट सही है? यू हैव टू नेम व्हिच ऑफ दीस स्टेटमेंट्स आर एक्चुअली करेक्ट. ओके, हाँ जी. तो फर्स्ट बताते हैं, हाफ ऑफ द अर्थ्स क्रस्ट इज कंपोज्ड ऑफ फेल्सपार. यस, यस इट इज, एब्सोल्युटली, बिल्कुल होता है. Around 60% of the Earth's crust is actually made up of feldspar. तो feldspar is found in a great quantity. Okay, light cream to salmon pink color. हाँ, वैसा ही shade. You will find the same shades. Those are the colors or hues that you will find feldspar in. Light cream to salmon pink. Okay. Magnesium is a common element in all types of feldspar. No, no, it is very famous to not contain iron and magnesium. Okay, feldspar is famously the one that is mostly made up of silica and not of iron and magnesium. Correct. Okay, so we'll go with that. So this would be wrong, and we will go with only 1 and 2. All right, okay. Moving forward. Consider the following pairs of with reference to sedimentary rocks and the process of formation, and you have to tell which of these pairs actually match. Okay, इसमें से कौन से pairs match करते हैं? The sedimentary rock and the process of formation is given as below. Chert, chemically formed. Gizerite, organically formed, and shale, mechanically formed. We'll go with chert, chemically formed. वो तो हमने पढ़ा था. Shale, mechanically formed, वो भी पढ़ा था. This is a problem, right? Gizerite जो है, that is a chemically formed. Remember, वो गीजर में से सब कुछ बाहर आता है, and then उसके बाद वो accumulations पीछे रह जाते हैं. जब वो पानी वानी सब evaporate हो जाता है, पीछे जो minerals रह जाते हैं, they usually form gizerite. Okay, so that is a sedimentary rock formed by a chemical way, in a chemical manner, right? तो ये मैच नहीं करता है. अभी मुझे यहाँ पे कहीं 1 and 3 का आंसर नहीं नजर आ रहा है. So thank God we are not appearing for this paper, because I don't know what to do in such a case. I don't know if UPSC ever goes wrong with a question. Does it generally give everyone the marks, or they generally सबको marks मिलते हैं जिसने attempt किया, right? तो फिर attempt करना जरूरी होता है उसको. तो आपको जो सही लगता है वो जवाब कर दीजिएगा. मैं बता रही हूँ आपको, इसका सही जवाब 1 and 3 होना चाहिए, जो ऑब्वियसली ऑप्शंस में लिस्टेड नहीं है. इट इज नॉट लिस्टेड विद इन द ऑप्शंस. ओके, फिर भी अगर हमको उस वक्त चूज करना होता तो हम क्या चूज करते हैं? 1 only, because 2 नहीं करेक्ट कर सकते, right? We can't choose 2. That is absolutely wrong. All right, moving forward. Question 110. Which one of the following is an example of both an igneous as well as a metamorphic rock? Gabbro, gizerite, mesoid और granite? नहीं, हमको मेटामॉर्फिक भी चाहिए और हमको ये भी चाहिए. ग्रेनाइट फेमसली इग्नियस, गैब्रो इग्नियस, गीजराइट सेडिमेंट्री. तो बचा क्या? mesoid. Okay, mesoid is going to be that which is igneous as well as metamorphic in nature. ठीक है, चलेगा? So we are going with option C. Which one of the following is correct? Pyroxene is commonly found in meteorites. Amphiboles form 20% of the Earth's crust. Quartz is soluble in water. The word sedimentary is derived from the word calimentive, Latin word calimentive. Let's consider one statement each, okay, at a time. Pyroxene is commonly found in meteorites. Yes, pyroxene is commonly found in meteorites. Pyroxene is the very common mineral जो आपको normally सारे extra terrestrial rocks में मिलता है, जैसे meteorites or asteroids. Mars has a lot of pyroxene, right, on the surface. So clearly we are talking of pyroxene as that mineral group which is found in meteorites. Okay, do amphiboles form 20% of the Earth's crust? No, they form about wait a minute, मेरे पास कहीं लिखा होगा ना होता है. राइट हमारे पास फेल्सपार्स जो होते हैं इन दी अर्थ क्रस्ट यू हैव फेल्सपार इन द क्वांटिटी समवेयर अराउंड 50 to 58% or 60%. Quartz is found at around 12%. Then pyroxene at around 11% and amphiboles at around 7%. 7% amphiboles होते हैं, 20% amphiboles तो नहीं होते हमारे पास. Okay, so we'll go with that. And mica and this even lesser. Quartz is soluble in water. Quartz is generally, if you consider at pure water, pure quartz at room temperature, then quartz is not soluble in water, right? Quartz नहीं soluble हो सकता है. अगर if you want the quartz to be dissolved in water, it has to be special conditions with very high temperature, high pressure वगैरह वो सारी special conditions दिए, so then quartz can be soluble in water. But for normal purposes, natural way में quartz is not soluble. Okay, the word sedimentary is derived from the word calimentum. So the word sedimentary is derived from the word sedimentum. I tried looking up Google for calimentum. There is no such Latin word called as calimentum. Cali does not make sense in Latin. Okay, okay. So no calimentum, just sedimentum. The word sedimentary is derived from sedimentum. Okay, okay. So we will go with 111 ka 8. We'll go with answer 8. Pyroxene is commonly found. This is the correct statement. The rest of the statements we cannot hold true. Okay. Which of the following is not an igneous rock? Granite, slate, basalt, or gabbro? Slate. Very good. Slate is the answer. Okay. Slate cannot be considered a igneous rock. Which one of the following statements about metamorphic rocks is not correct? Due to segregation of minerals into wavy bands or platy surfaces, some metamorphic rocks develop foliations. Where the foliations develop into broad mineral bands, the metamorphic rock is extremely hard. When the foliations are moderately thin, the metamorphic rock tends to flake apart. The rocks that originally were composed of one dominant mineral are often foliated by metamorphism. Okay, now we are talking specifically about foliations, all right, about the process of foliation. Now you are saying that because of the segregation of minerals into wavy bands, segregation is separation. Okay, because of the segregation or separation of minerals into wavy bands or platy surfaces, metamorphic rocks develop foliations. This is true, right? Foliations are developed because these minerals separate themselves into lines. Okay, so this statement is absolutely correct. Where the foliations develop into broad mineral bands, the metamorphic rock is extremely hard. The reason why the foliations are happening, what is the reason why the foliations are happening? Because this mineral reacts to stress in a different way than the rest of them. Okay, so clearly the rock is subject to a lot of pressure. Okay, if the rock is going to be a metamorphic rock, if it is subjected to be a lot of pressure, what is the physical quality it is going to acquire? Hardness, right? So clearly, जहाँ कहीं pressure ज़्यादा apply होगा, enough to have foliations, the rock is going to be harder. Okay, this is the statement holds true. Statement C देखिए, where the foliations are moderately thin, the metamorphic rock tends to flake apart. कि जहां पर foliations thin होते हैं, the rock will flake apart. Flaking माने पता है कैसा? वो जैसे पेंट निकल आता है ना, वॉल का पेंट निकल आता है या फिर प्लास्टर निकल आता है, that is called as flaking. तो मेटामॉर्फिक रॉक का फ्लेकिंग पॉसिबल हो सकता है क्या? बोलिए. नहीं, मेटामॉर्फिक रॉक में फ्लेकिंग नहीं हो सकता है. ओके, फ्लेकिंग के लिए थिन शीट्स ऐसे बाहर निकल आते हैं, नहीं हम स्लाइसर से स्लाइस करते हैं पोटैटो को वगैरह, तो वैसे वाला होना चाहिए. तो ऐसा फ्लेक नहीं हो सकता. मेटामॉर्फिक रॉक कैन नॉट फ्लेक लाइक दैट. ओके, इट कैन बिकम it can be susceptible to erosion, it can be susceptible to weathering, it can break, it could possibly break, but flaking नहीं होता है metamorphic rock में. Okay, so we are not going there. Rocks that were originally composed of one dominant mineral are often foliated by metamorphism. Yes, that makes sense. One dominant mineral which will get aligned in a different way than the rest when subject to pressure. Yes, that is foliation. Question 138. Rocks do not remain in their original form for long and undergo transformation. Transformation of rocks is caused by weathering, erosion, and metamorphic action. Yes, all true. है ना? We say that rocks do not remain in their original form for a long time. Yes, absolutely true. And they undergo transformation. Yes, they do. Transformation of rocks is caused by weathering, erosion, metamorphic action. All of them, right? Weathering से भी rocks change हो सकते हैं, erosion से change हो सकते हैं, and clearly they can change because of metamorphic action. Okay, so all of this is going to be true. Everything is true. Which of the statements given below are correct? All both are correct. Both 1 and 2 are correct. Okay, we'll go with this answer. Okay, weathering, mass wasting, erosion, and transportation are indicators of which of the following processes? Denudation, endogenic processes, diastrophism, and mountain building. Weathering, mass wasting, erosion, and transportation are indicators of which of the following processes? Denudation, endogenic processes, diastrophism, mountain building. Mountain building में क्या होता है? Compressional forces are applied or tensile forces are applied. Block mountains are formed, fold mountains are formed. That is mountain building. Okay. Weathering से उसका कोई वास्ता नहीं है. What is diastrophism? Very slow deformation of the earth. Okay. So epirogeny, orogeny, that is diastrophism. Okay. Very slow deformation of the earth. So clearly that also has very little to do with weathering, mass wasting. We are talking of tectonic forces acting over here in case of diastrophism or mountain building. Endogenic processes क्या है? यही सब. Mountain building, orogeny. So this only. What is denudation? All the processes that we are talking of earlier, weathering, mass wasting, erosion, transportation, these are all used to bring the relief of a landscape down. Okay, bring down the relief of a landscape and lower the relief and clearly removal of layers one by one. Okay, what is this process essentially called as? Denudation. Okay, this process is essentially denudation. So that's going to be your answer. Which one of the following is not a soil forming factor? Parent material, topography, climate, or human habitation? Which of these factors do not influence the process of the formation of soil? Human habitation. Absolutely correct. See people, parent material important hota hai. It is the parent material which decides what sort of soil is going to be formed, right? Which minerals it will be composed of, what it will have. Ye sab kuch, all that is decided by the parent material. The topography is important because, say, suppose you are in a humid climate. It is going to affect the quality of the soil. It is going to affect how the soil is being formed. Say, suppose you are in a sandy, arid climate or a sandy, arid place, an arid place, okay, an arid climate. Clearly, the soil is going to be affected in that way, okay? So, topography will change. Say, even for example, let's say like this, if you are forming soil on a gentle slope, okay? If it's a gentle slope, the soil will stay there for a long time. But if it's a steep slope, if the slopes are very steep, then clearly the soil will not stay in a place and the formation process does not happen clearly fully well. So clearly it will not help. Climates help, topography helps, parent materials help. It is only human habitation that will not contribute in any which way to the process of formation of a soil. Okay? ठीक है? वो English so गए. So now I can explain partly in Hindi. Which one of the following sedimentary rocks is organically formed? Shale, chert, halite, chalk. Organic चाहिए हमको, organic. Chalk. Chalk, limestone, ये सब कुछ organically formed होता है. Okay, so we'll go with chalk. Shale क्या है? Shale is mechanically formed. Chert क्या है? Chemically. Halite chemically formed. Okay, so that will not work. Which of the following? The same question, right? Which one of the following is not an agent of metamorphism? Heat, compression, decomposition, or solution? हाँ, ऐसा लगता है हमको लगता है वो weathering है. But actually, this is a problem. See how the thing is now we consider decomposition, process that we call as decomposition, where the minerals break down and change themselves. That is technically called as devolatilization or something like that. It is not technically called as decomposition. Decomposition we maintain only specifically for organic matter breaking down. Like if you're looking at very technical definitions, then decomposition is like that. Whereas solution, though ideally it is a weathering wala process, लेकिन solution जो होता है वो हम specifically छोटे छोटे केसेस में नहीं, वो ऐसे कार्बोनेशन के प्रोसेस में डिसॉल्व हो जाता है एंड ऑल, तो उसके लिए हम वो उसको डेफिनेटली यूज करते हैं. ओके, सो वी आर सेइंग कि वो सॉल्यूशन वैसे सॉल्यूशन इज आइडियली अ पार्ट, इट इज द डिकम्पोजिशन दैट डज नॉट वर्क. ओके, सो वी आर गोइंग विद डिकम्पोजिशन बिकॉज वो ऑर्गेनिक मैटर के लिए रिजर्व करते हैं हम लोग. बोल लीजिए 145. Which one of the following is not an igneous rock? Gabbro, granite, dolomite, basalt. Dolomite, yes, dolomite. Dolomite and limestone जो होते हैं वो famously ये rocks है, sedimentary rocks है, organically formed sedimentary rocks है. Okay, and we are done. We can move away from rocks as well. Now we go to weathering. चलो, now we looked at rocks also. अभी हमने rocks भी देख लिए. अभी हमको जो करना है, that is now we are looking at proper exogenic processes. So we will look at weathering and erosion. Okay, erosion deposition. So we are basically looking at the formation of landforms, and we are looking how weathering happens. Girls at the back, keep your voice down. Okay. So the first process is weathering is a part of exogenic processes. Okay. Exogenic meaning where the surface of the earth is changed due to external factors. Okay. That is exogenic processes. So endogenic process, please remember, endogenic processes जो होते हैं, they will build the earth, whereas exogenic process will bring down the relief. Okay. That is the general idea. They will wear it down. And the types of exogenic processes are weathering, erosion, deposition, and mass wasting. Okay. So over here, we are going to try to cover weathering and mass wasting. Those two are definitely going to be covered today or in this particular chapter. So denudation means weathering and erosion together. Denudation meaning peeling off layer by layer of the earth. Okay, where will that happen? Only in weathering and erosion. Okay, it breaks down. Girls, next time I will have to ask you to leave the classroom. If you want to leave right now, do it. Do so. Okay. Weathering takes place in situ. Okay, weathering जो होता है that takes place in situ माने in place. This is a Latin term for something happening in place. It does not change places. Okay, whereas erosion जो होता है वो dynamic process होता है. See what happens is there is a glacier or river water or something like that coming from far away. Okay, it works on this rock and it carries the material forward. Okay, what happens in a weathering is the rock is sitting in one place, and because of heat, temperature changes, pressure changes, volume changes, what happens is the rock starts breaking. बैठे बैठे in one single place, बैठे बैठे the rock starts breaking up, and because it becomes weak, it weakens down, it starts crumbling and breaking, and then breaks down completely and turns into soil. Okay, that is the process of weathering. Okay, it is not dynamic as the process of erosion. Weathering always happens in situ. Okay, please remember this Latin term, in situ meaning in place. Okay, it's happening in the same place, this term. This is the term, okay, that we are looking at. Okay, now exogenic processes के अलग अलग factors कौन से होते हैं? One, first of all, gravitational force काम करेगा. Mass movement तो बिना gravitation के काम कर ही नहीं सकता है, right? It cannot work without gravitation. It has to come down something, right? The gravity has to happen. Stress is another important factor. For example, there are temperature changes. The temperature becomes too high, the temperature becomes too low. The rock expands, the rock contracts. Okay, so these set up the temperature changes will set up volume changes. The volume changes will cause stress, and eventually the rock will break down. Okay, so that will lead to disintegration or deformation. Temperature is an important factor. Like we discussed, low temperature, high temperature, changes in temperature. Water and precipitation is again important for exogenic processes because it will, the amount of precipitation will affect both the erosion as well as the weathering process. Okay, vegetation is another important factor, especially in erosion. Especially in weathering. Biological weathering is a good factor in weathering. Okay, anthropogenic activities. Oh, hello. Anthropogenic activities माने human beings जो activities करते हैं, activities performed by human beings. Okay, they will change. What we do is we want a road. Okay, so we will go dig through a mountain, make a big tunnel, take away the support from the overlying piece of mountain, and then later it can fall down as landslide. We are fine with that. Okay, we'll make arrangements for that as well. So clearly what happens is anthropogenic activities or human activities will contribute a lot to weathering. If the weathering was naturally going to happen, say in about 10,000 years, we'll make it happen in about 100 years. Okay, we accelerate that process so much. Human beings by their activities usually accelerate that process a lot. Okay, so we are also responsible in part. Of course, exogenic activities will vary from region to region. अब मुझे बताइए, रिवर की वजह से जो इरोजन होता है, क्या वो हर जगह सेम होता है? नहीं, है ना. रिवर अपस्ट्रीम अलग इरोजन कराता है, डाउनस्ट्रीम अलग इरोजन कराता है, राइट? क्लियरली, बिकॉज वो स्पीड में होता है अपस्ट्रीम, तो वहां पे वो बहुत डिफरेंट इरोजन कराएगा. डाउनस्ट्रीम उसका तो डेपोजिशन का काम होता है. सो इट विल वर्क डिफरेंटली इन डिफरेंट प्लेसेस. जहां पे रिवर का पानी नहीं है, वो इरोजन करा नहीं सकता है, राइट? सो इन डिफरेंट प्लेसेस, रीजन टू रीजन वो अफेक्ट करेगा. विंड का इरोजन जो होता है वो सबसे ज्यादा कौन सी जगह पे होता है? वेयर डू यू सी द मैक्सिमम विंड इरोजन? डेजर्ट्स. एब्सोल्युटली, डेजर्ट्स में सबसे ज्यादा, बिकॉज विंड को खुला एरिया है घूमने के लिए, राइट? इट हैज फ्री स्पेस टू रोम अराउंड. सो क्लियरली डेजर्ट्स आर द प्लेस वेयर विंड विल वर्क द बेस्ट. सो it will vary from region to region what is working there. All right, and it will depend on the rock climate combination. Especially you're looking at weathering, it will depend on the rock climate combination. Blue shirt, cream color shirt. Yeah. Happy? All right. So that will depend on the rock climate combination also. Which rock will work in which climate. For example, Granite works best. Granite is resistant everywhere actually, but sandstone works best in warm, dry climates. Arid climates में sandstone को कुछ नहीं होता है. But यही आप contrast कर दो, put it in a humid climate, sandstone को किसी humid climate में डाल दो, तो chemical weathering की वजह से उसका काम खत्म होता है. Okay, limestone dry climates में absolutely great. Look at the cliffs of Dover. Okay, but नहीं, यहाँ नहीं है. Hey, cliffs of Dover. I can show you the cliffs of Dover. They are interesting cliffs. मेरा favorite चीज होता है वो cliffs of Dover. So you will understand how how limestone works. Those are the cliffs of Dover. Magnificent, right? So clearly, in that dry climate, in that dry temperate climate, more limestone के cliffs एकदम impenetrable है, very resistant out there. Okay, but put that in a place like Yugoslavia, जहाँ पर पहले Yugoslavia होता था, past region में होता था, वहाँ humid climate में उसको डाल दो, limestone ऐसे झट से खत्म हो जाता है. Okay, so rock climate combination is also important for that. It's very important for that. Okay. And lastly, it will depend upon the type and structure of rocks, the different rates of erosion in different topography. Like you will have like if it's a, how do you say, if it's a dry topography, clearly the erosion will work different for different things. And if it's a humid topography, this humid topography as in not exactly humid. We are looking at say glaciers, एक certain जगह पे glaciers high slopes पे बहुत better काम करते हैं, लेकिन low slopes पे काम नहीं करेंगे. Okay? Because erosion का उतना weight नहीं मिलता है उसको, gravity नहीं मिलती है. ठीक है, here we go. The first this of weathering. Weathering क्या होता है? It is the process of boys at the back split up. Second वो plaid shirt, आपके साथ जितने भी बच्चे बैठे हैं उनको सामने बिठाइए. Plaid is check shirt. हाँ जी, yes you. हाँ, तो हाँ वो जो ग्रुप है वो सारा बेंच उठ के कहीं और जाएगा. हाँ उनको भी लेके जाओ. You mind? No, you get it from there. Come and sit here. Blue shirt, yeah. And the other one, the guy who's now bending down. Yeah, get up, sit over here. You're free to leave the class. I have no clue why you're sitting over here and wasting the time away. You are adding spice to that group, are you? All right, well then. It is the process of mechanical disintegration. Mechanical matlab the process is not chemical in nature. Please understand, we are not talking of chemical reactions. We are talking of stresses involved and the breakdown that follows. Okay, the mechanical disintegration and chemical decomposition of rocks through actions of weather and climate. Okay, so we are talking of both the physical as well as the chemical way in which the rocks can be broken down. All right, now this is the classification for weathering. It can be chemical. Can you guys see? No, not much. It's all right for you. Okay, so chemical, physical and biological kinds का weathering होता है. Chemical weathering जो होता है उसमें clearly ये चार processes involved होते हैं: solution, carbonation, hydration and oxidation and reduction. Okay, that can be that. Physical weathering में unloading expansion हो सकता है, thermal expansion हो सकता है, freeze thaw weathering होता है, salt weathering होता है, granular weathering and block disintegration. Okay, these are the 6 different. I have listed only 4. I have just realized that, but there are 6 different processes for physical weathering. Okay. Biological weathering can happen because of animals or human beings. So, or trees can also do that. So trees cause wedging. Human beings are responsible for plowing and all. Small animals, like those ground hogs जो होता है, सुना है कभी, देखा है कभी? So they can burrow. They can really burrow through the soil. Okay, and they can cause more harm. So plant roots and obviously biochemical reactions like decay can cause even more further weathering. Okay, ठीक है? चलो जी, फर्स्ट केमिकल वेदरिंग कंसिडर करते हैं. We are saying rocks जो होते हैं वो decompose होते हैं. See, rocks can properly be decomposed. Once again, the word used here is decomposed, but what we are essentially saying is that the original material is transformed. Okay, They can be decomposed, dissolved, and reduced. We are talking of decomposition, dissolution, and reduction. Okay, so agents involved are water. This is a chemical weathering. Clearly, we cannot work without water. Okay, and heat will act as a catalyst. The main thing that we want is water. The heat will always act as a catalyst. Okay, and air चाहिए, oxygen, carbon dioxide will sometimes aid the whole reaction. All right, usually ये processes जो होते हैं, they go hand in hand. The ideal situation is कि पहले chemical weathering हो जाए और फिर उसके बाद अगर जब physical weathering हो जाता है तो rock पूरी तरह टूट ही जाता है. Okay, the rock will break down completely. So ideally, the first thing that should happen is the chemical weathering, or then let the physical weathering happen and let it follow by chemical weathering, or let the chemical weathering happen and let it follow by physical weathering. Usually, depending on where the rock is situated, what climate is it situated in, and what topography it is in, one kind of weathering is going to be really dominant. The rest two are going to be mild. Okay, the rest two are pretty mild there. All right, but there will be at least one weathering which will be pretty dominant and pretty severe. All right. आप उठिए अपनी जगह से और यहाँ जाके बैठिए, वो ग्रीन शर्ट के साथ जाके बैठे. अरे वो क्यों जाएंगे, वो तो शांति से मोबाइल पे खेल रहे थे. आप उठिए. हाँ. मॉनसून रीचेस केरला. अच्छा, हमारे पास 2 दिन में आ जाएगा. ठीक है. गेट अप सर. कोई इनविटेशन देना पड़ता है सब करने के लिए. अभी इनको किताबें चाहिए. चाहिए यार. इनको खराब मत कीजिए. वो वहां जाके बैठिए, ग्रीन शर्ट के साथ बैठिए, या उनके आगे के बेंच पे बैठिए. Okay, chemical weathering. The first kind of weathering that you see is solution. Can you see the rock? उसके ऊपर के गड्ढे दिखाई दे रहे. कैन यू मेक आउट द होल्स ऑन द रॉक? दैट इज द रॉक बीइंग डिसॉल्व्ड. वो डिसॉल्व हो गया है वो रॉक कंप्लीटली, एंड व्हाट इज लेफ्ट बिहाइंड इज प्रॉपर हॉलो स्पेसेस. ओके, सो सोल्यूशन में क्या होता है, मिनरल्स जो होते हैं, व्हाटएवर मिनरल्स एग्जिस्ट विद इन द रॉक, दे आर डिसॉल्व्ड इन द वाटर, आइदर इन वाटर और वीक एसिड. ओके, सो इफ दे आर गोइंग टू बी डिसॉल्व्ड इन वाटर और वीक एसिड, क्लियरली अब वीक एसिड कौन सा होता है? कार्बोनिक एसिड होता है. वाटर मिक्सेस विद कार्बन डाइऑक्साइड, फॉर्म्स कार्बोनिक एसिड, and that carbonic acid can take away carbonates, bicarbonates from the rock. Okay, meanwhile sometimes normal minerals जो होते हैं, they are also sometimes soluble in normal water at normal temperatures. Okay, so this also, once again, this process will work as long as the minerals are soluble. Can all minerals dissolve in water or carbonic acid? No. Okay, there will only be a specific amount of minerals that can be dissolved in water or carbonic acid, and only those will get washed away. Okay, and when those minerals are washed away over time, this is how the rock starts looking, because it will turn hollow in places where the minerals used to be originally. Okay, okay. So solution may clearly these minerals, some of these minerals are dissolved or removed from the rock by water or weak acids. And in case of carbonic acid, it will be carbon dioxide dissolved in water. And usually the process will depend on how soluble the minerals are in the water. Okay. Now, can we do this without water? This is a chemical process. Can this be done without water? No. So what kind of climate do we want to be in? A wet climate, a humid climate, okay, where there is at least presence of water in the form of precipitation or in the form of humidity. Okay, so that is where this kind of process will work the best. All right, this does not mean that it does not work in different places, but it will work most effectively in the most optimum fashion when such a rock, a water soluble rock with minerals, rock having water soluble minerals, is placed in a humid or a wettish climate. Okay, that is where this is working. Most notable examples of these are limestone and sodium chloride, right? It's namak and limestone work best in for chemical weathering for solution. Okay, calcium carbonate and calcium magnesium carbonates jo hote from limestone, they are easily dissolved in carbonic acid, so that happens to be important. This kind of solution also works best if you have pore spaces. But sometimes sedimentary rocks have pore spaces, larger grains. If the grain size is larger, then clearly between those two grains a little pore space is left. Okay, the water can lodge itself within it and reach more more of the rock in that way. And that is why it is usually better if the pore spaces are larger for solution. It will also work best with granite, because granite is a well-jointed rock. There are proper joints, meaning there are proper cracks through the entire rock, so that water can travel through that crack. Okay, and it is most effective in tropical climates with heavy rainfall. You need water and you definitely need heat. Heat will always act as a catalyst for chemical processes. Are we good here? I'm assuming you are. People, unless and until you actually say that you did not understand anything, I'm going to assume that you did understand everything. Okay. And I'm going to declare to Bhaiya that I have taught this to this group of people and they have nodded their head saying they did understand everything. Okay. My part is done. Huh? Let's remember that. Okay. Carbonation. The next process of chemical weathering is carbonation. Carbonation में क्या? Carbonation पता है? Carbonated drinks पता है? You all know what carbonated drinks are. What are carbonated drinks? You mix carbon dioxide in water in a very pressurized form, right? And that is how it remains in the form of that fizz. It remains as carbonated, right? Similar process for nature also. We are saying that the carbon dioxide from the air mixes in the water while it is raining in the form of precipitation, और जब वो ground water होता है तो उसमें जाके वो carbon dioxide mix हो जाता है and that forms carbonic acid. Okay. Now this carbonic acid, when it reacts with the minerals of a rock having calcium carbonate or a calcium bicarbonate or something like that, it is going to dissolve those carbonates and bicarbonates. Okay, it is going to absorb and take away with itself all the carbonates and bicarbonates from the rock. Okay, sometimes leaving such a hollow space. ये बाजू वाला जो hollow space दिखाई दे रहा है, ये cave वैसा hollow space रह जाता है. Okay, usually what happens in this case is ये आपको जब हम karst topography study करेंगे, when we'll study karst topography in landforms, this is a very important factor. Usually you will find limestone beds, okay, huge limestone beds as the bedrock or as the proper rock. Okay, now usually what happens, there is groundwater running above it. All right, okay. Now if this mixes with the carbon dioxide, that forms carbonic acid, right? I'm not even asking for precipitation here. We're not even praying for precipitation. We are just saying this will even work with groundwater. Mostly it works with groundwater itself because it is in a semi-arid place. Okay, humid semi-arid place may be kam kar jayega as long as groundwater is available. Only thing you need is the carbon dioxide to mix with the groundwater. The groundwater, when it mixes with the carbon dioxide, forms carbonic acid, weak carbonic acid, which still has the capacity to dissolve carbonates and bicarbonates. Okay, तो इस पत्थर के अंदर जितने भी carbonates या bicarbonates होते हैं, they get dissolved, and वो पत्थर is left hollow. The पत्थर, this entire thing, it will try to dissolve this place, make an entrance into here, and this entire solid patthar somehow turns into like this. That entire solid block of limestone turns hollow. Okay, you can see this hollow shape. This hollow shape, that is what it becomes because of the entire process of solution. Okay, solution and carbonation together work in this fashion. Okay. Okay, the residue is removed sometimes completely, and what is left behind is a hollow space. Okay, sometimes even the calcium residue is not left. Normally, you can see this is the calcium residue, right? This stalactites, stalagmites, you can see those, right? So that could be considered as the calcium residue. Sometimes even that is not left behind. All you see is a hollow space. All right, okay. So a famous example for this is limestone caves. This is important. This is hydration. Hydration means being filled up with water. Okay, water is being added, but in this case, the water is being added chemically. We are not saying we are sprinkling the soil with water. We are saying the water is added chemically. It is added to the minerals itself. Okay, it's a chemical addition. The minerals will take up the water and they will expand. Okay, the minerals will expand, and when they expand, see now the process, the starting of the process is chemical. All right, the water is taken in chemically. Okay, the effect of that is a little physical because now the volume will change. Since the volume changes, stresses are set up, and because of the people stresses what something, it is a reaction to something abnormal, something unusual, right? That is stress. We agree that, right? That is something that works in a similar fashion in our body as well, right? Stress is something that is developed when something unusual keeps happening over and over again. Okay, that is a stress. So if the volume is supposed to remain this much and suddenly it is this much, then clearly that is a cause for stress. Okay, so these stresses, this unusual activity is set up in the rock as well, and because of that the rock starts to break down. Okay, because of this volume change, and why the rock starts to break down. And why did the volume change? Because water was added chemically. Okay, so this is hydration. The famous examples for this is calcium sulfate. One, calcium sulfate का क्या हो जाता है? Once you add water to it, it turns into gypsum, and gypsum is very unstable. Okay, anyone will tell you gypsum is unstable. Clay का तो पता है, we played with clay all our lives, right? You add water to it, you can play with it. It becomes it is left out to dry. It starts cracking up. Na? That is clay for you. So salts in pore spaces, that will also undergo hydration if they are उसका अगर rapid drying and wetting करवाया तो उससे भी rock break down कर सकता है. And volume changes will greatly. It is like I said, it is a mixture of chemical and physical weathering. The process of taking in the water is chemical. The effect is physical. Okay, the effect is physical. All right, moving forward. Oxidation and reduction. Oxidation reduction पता है, right? Addition of water is addition of oxygen is reduction. Addition of this is hydroxide is reduction. What am I saying? Addition of oxygen is oxidation. Addition of hydroxide is reduction. All right. So oxidation means the combination of a mineral with oxygen to form oxides or hydroxides. Okay, that is what we are looking at. So the most common thing that we see is rust. है ना, ferrous iron के साथ जब oxygen add हो जाता है तो उसका फेरस ऑक्साइड बनता है, फेरस या फेरस फेरस ऑक्साइड बनता है. ओके, तो फेरस ऑक्साइड बनता है. एंड ऑब्वियसली ये जो ऑक्साइड्स होते हैं दे आर वीकर देन द ओरिजिनल वन. ओके, they are much weaker. Can I hold a piece of iron, a non-rusted piece of iron, and do this to it and expect something to fall off? No, right? I can do this to rust. I can scratch it off with my fingernails. Can I? We all can, with a little wrist to your fingernail, but you can still scratch off the rust, right? So we are saying that usually as long as water is available, and we do not need proper precipitation also, a little bit of moisture is fine. Okay, so we are saying as long as moisture is available, because that is going to be the water, and oxygen is available, because that is always, the air is always full of oxygen, so oxygen you'll find in the air. As long as there is exposure to atmosphere and water, rustring, this oxidation process can definitely happen. The most commonly affected minerals by these are iron, manganese, and sulfur. Okay, these are the minerals that will commonly form oxides, and usually the oxides are much weaker than the original mineral or metal. Okay, they are much weaker, and because of that, the rock starts breaking down. Okay, this is a rock actually, over which you can see the whole formation of rust and everything. Okay, obviously जब oxides बनते हैं, the color is a little brown or yellow. Okay, यही if you expose it to waterlogged conditions, जहाँ पे आप ऑक्सीजन का intake control कर रहे हो. Okay, waterlogged conditions में obviously oxygen नहीं मिल रहा है आपको, so stagnant water या waterlogged conditions में, in absence of oxygen, the process of reduction will happen, the reaction of reduction will happen, and in that case the hydroxide so formed will have a greenish or bluish gray color. Okay, that is the different color. Have you ever seen किसी रिवर के पास या पॉन्ड के पास छोटे छोटे पेबल्स होते हैं? हैव यू सीन लिटिल पेबल्स ओवर देयर? एंड द वाटर विल नॉट फ्लो फ्रॉम देयर. ओके, द वाटर हैज टू बी stagnant. Sometimes the river will have a greater flow in the middle, but over the near the banks it is pretty stagnant, right? So if you check out the stagnant water and the pebbles over there, you will see they have this color, this greenish bluish color. I'm not saying the algae over it, I'm not talking about the algae developed over it. I'm saying the color of the stones itself has altered a little because of the reduction reaction. ओके, ठीक है, ये तो देखा होगा आपने. दिस इज वेरी कॉमनली फाउंड. द रस्ट इज कॉमन, but you should check out the waterlogged conditions, especially in your places where the water does not flow very easily. तो वहां पे you will find those stones which are turned a little greenish or bluish gray. Okay, does that finish off? Yes, that finishes off chemical weathering. chemical weathering पे questions देख लो क्या? ये वाला बताइए. Which one among the following processes is not a part of chemical weathering? Solution, hydration, reduction, forming. Most definitely point. Okay, solution is definitely a process for chemical. So is hydration, so is reduction. और नहीं. ये वाला process बताइए. The process where certain minerals absorb water, expand and change is called as hydration, oxygen, hydrolysis, या carbonation. Hydration. What is hydrolysis as opposed to hydration? Breaking of water. Yes. Breaking of water. Carbonation में clearly carbon is being added to water, and oxidation में clearly oxygen is being added, oxides are formed. Okay. Which of the following is not a process of chemical weathering? Solution, carbonation, oxidation, exfoliation. Exfoliation. This is a very typical mechanical process. You have not seen this so far. Okay. So solution, carbonation, oxidation are all processes for chemical weathering. Exfoliation isn't. Chemical weathering of rocks is much greater in a place with cold and dry climate, hot and humid climate, hot and dry climate, cold and humid climate. Hot चाहिए and humid चाहिए. Very good. Hot and humid. Like I told you, the heat will act as a catalyst. The water is essential. Water is necessary. आपको chemical reactions के लिए पानी चाहिए, पानी. हाँ वो हीट तो एडेड एडवांटेज है, लेकिन हीट जब मिलता है तो फटक से हो जाता है सब कुछ। ओके, सो विल गो विद हॉट एंड ह्यूमिड क्लाइमेट। डिड यू गेट एनीथिंग? ओके, ऑलराइट। मैं आपको जनरली इंट्रोड्यूस कर देती हूँ फिजिकल वेदरिंग से, फिर नेक्स्ट सेशन में फिजिकल वेदरिंग करेंगे। ओके, तो फिजिकल वेदरिंग जो होता है दैट इज फिजिकल डिसइंटीग्रेशन ऑफ रॉक्स। ओके, डिसइंटीग्रेशन मीनिंग ब्रेक डाउन। सो हियर द रॉक्स आर ब्रेकिंग डाउन ड्यू टू प्रॉपर फिजिकल प्रोसेसेस, स्ट्रेसेस आर बीइंग सेट अप, टेम्परेचर चेंजेस होते हैं, वॉल्यूम चेंजेस होते हैं, द स्ट्रेसेस आर बीइंग सेट अप बिकॉज ऑफ दीज चेंजेस, एंड हेंस द रॉक स्टार्ट्स टू ब्रेक डाउन। ओके, when it breaks down it can break into granular forms, or it can break, like in case of in case of sandstone it will break into grains, but in case of granite it will break down into proper blocks. Okay, there will be proper blocks over there. So the forces involved will be gravity and stress due to expansion compression. Okay, the stress is the most important factor here, and gravity is another important factor because without gravity nothing else in the world works. Okay, it is most effective when the rock is already made weaker by chemical weathering. So once again, it works best if the chemical weathering has already worked on the rock, and then the physical weathering works. But usually in a particular environment, in a particular climate, one kind of weathering is always going to be dominant. Okay, one sort of weathering is always dominant. So if you're talking of physical weathering, if a rock is undergoing physical weathering, then clearly it is in a hot, dry, it's in a hotter, cold but drier place. Okay, it is usually in an arid place where usually physical weathering works best. Okay, so we are talking of that. इसके ना मैं आपको जनरली इंट्रोड्यूस कराती हूँ द जनरल दिस फॉर फिजिकल वेदरिंग, प्रोसेसेस फॉर फिजिकल वेदरिंग आर अनलोडिंग एंड एक्सपांशन। इसको प्यार से यूपीएससी एक्सफोलिएशन बुलाता है। ओके, या अनियन शीट्स, अनियन पीलिंग बुलाता है। सो वो इस नाम के लिए प्लीज रिमेंबर दिस, क्या बोलते हैं, this particular method of physical weathering. Okay, they love to ask you questions on exfoliation or onion peeling. So unloading and expansion का एक method होता है. Then there is obviously thermal expansion. You can see the rounded off. Can you see this particular rock? The sides are rounded. No, most of the sides are pretty much rounded. The outer surface of the rocks gets affected most. That is thermal expansion for you. And then of course there's granular weathering. The entire rock starts crumbling down in grains. You know, bread के जैसे crumbs गिरते हैं ना? नहीं, आपके ब्रेड के नहीं गिरते, किसके गिरते हैं? टोस्ट के क्रम्स गिरते हैं, राइट? हम जो अच्छा टोस्ट खाते हैं उसके क्रम्स गिरते हैं। तो क्रम्स और किस चीज के होते हैं? व्हाट आर द थिंग्स एज क्रम्स? लड्डू, लड्डू के क्रम्स होते हैं, है ना? हाँ, मोतीचूर के लड्डू के क्रम्स होते हैं, राइट? गुड। ओके, सो वी आर सेइंग जैसे क्रम्स होते हैं तो अच्छा, यू डोंट नो व्हाट मोतीचूर का लड्डू इज? Oh, you understand what crumbs are, right? You understand crumbs from toast or something, right? So this the rock starts breaking down into crumbs and grains, and it starts to disintegrate. It will come off in grains and crumbs. Okay, that is granular weathering. Block disintegration में ये Thanos का gauntlet. This is being formed because the entire granite rock is made up of blocks. Okay, it is not made up of blocks. It has cracks. Okay, the entire rock is jointed, and wherever the joints are, they get expanded into cracks, and then such blocks are formed. Okay, that is block disintegration. This is thawing, freezing and thawing. अच्छा खासा rock रहता है. It looks like you've cut a knife through it, right? So अच्छा खासा separate हो जाता है वो. That is free. That is in a high latitude, high high altitude place usually where freezing happens. Okay, and the last of this is salt weathering. Please do not confuse salt weathering with any kind of chemical weathering. Please remember, salt weathering is very specifically physical weathering. Okay, UPSC asks you this. I have at least 3 questions based on salt weathering in my list of questions, and that is because salt weathering can easily be misunderstood as something that belongs to chemical, but it is very physical in nature. Okay, it is about the volume changes of salt particles. All right, ठीक है? We'll end here. I don't know which class you're going to. Guys, मैं ये लेक्चर ऊपर एंड कर दूं और नीचे चले जाओ मीट रूम में। ठीक है, तो वो नीचे आ जाएंगे ना मीट रूम में डायरेक्टली।